Okay, test. Should be live. Hello, everyone. Welcome back to the stream. I'm starting a tiny bit early this evening because there is a ton I want to accomplish this evening. There is a lot of work in front of me, and I'd like to get as much of it done as possible, hence, starting a bit early. So, what I want to do this evening, to answer that, let's start by where we left off on Tuesday. On Tuesday, I started continuing the work on function analysis, as in name checking, type checking, and so on. And we're still in the process of like, okay, we have an expression in the context of a function. How do we name check it? How do we type check it? What do we output? All of that. And I was looking specifically at struct expressions and field access expression. So I have an expression in which the left-hand side I know must be some kind of struct, and on the right-hand side I have the name of a field, like something.x, that is supposed to extract the x field from that struct. The problem is, to know whether this is valid, to check that this is correct, to do all of the analysis, I need to know how the structure was defined. And this is where I identified a problem that is not a blocker yet, but that is fundamental enough that is worth rethinking a bunch of things. And the problem is this. Imagine I'm currently compiling module A, whatever that module happens to be, and it imports a function from a module B. So the name of that function is in scope, and we can do all the resolution, check that the function code is fine, check the types, everything is fine. But that function returns a struct that was defined in module C that B imports. That's perfectly fine. But module A does not import that struct because module A does not import module C. When it comes time to check that, okay, I've called this function from B and I want to extract a field from the result, how do I get the definition of the struct that function in B returns if I'm not importing C? Because at the moment, the scope, everything I have in scope when I'm compiling a given module A is for everything I've imported, the identifiers of the things in scope. When I call a function, through which one am I calling, where is it defined, where is it coming from, and for each unique name, which is that thing on screen at the moment that I'm going to change, what's the definition associated with it if there's one? The problem is I'm only looking at the modules I'm importing. So if I do this, I import the function from B, I call it, I get a struct, and I have no way to know what the definition of that struct is. So out loud on Tuesday, when I realized this problem, I wanted to explore two different approaches to solve this. The first is, okay, well, when we do the whole compilation, when we build the actual binary that does the incremental compilation of each module, we keep a cache within of all the definitions we have ever encountered. That way, within A, when I'm compiling A, if I need the definition of the struct that was originally defined in C, I have access to it because I have underneath this gigantic cache of all the definitions. The other approach is the one you see currently on screen that is not committed, and I'm going to revert because it's not the correct approach, but I toyed with, which was, at the moment I have a layer of indirection between the name of something in my scope and the original definition. I'm calling, let's say, a function foo in my code, so I have to look at my scope, what things are named foo in my scope. I find the corresponding name, which uniquely identifies something in the context of our program, and then I can do a second lookup from that name to the definition. What if I remove this? What if the name also contained, as it does here in there, contains a pointer to the declaration? That means every resolved version of a function, of a structure, of anything contains a pointer to the definition of every single thing it mentions. The upside is we don't have to maintain the cache. We don't have to depend on other modules and everything. We don't have to have this infrastructure in place because every single resolved expression contains a pointer to the definition of the thing. The downsides are, well, a small downside would be duplication, because since each name would contain a pointer to the declaration, if we end up doing some serializing, deserializing, there would be a bunch of duplicated copies of the declaration everywhere, which runs into sync issues, and so on. It would also make doing equality comparisons on the name, which is supposed to be unique, a bit more difficult because like we would have to ignore the declaration. It makes everything more complicated. But there is a deeper problem with the second approach, which is that it breaks something fundamental that we've done so far, and therefore is not the right solution. And the reason, what it breaks is the reason we have this layer of indirection of like from a name in scope, from an identifier in scope, we associate a name that uniquely identifies the thing from which we can then look up a declaration, is that the idea of this is if we have a structure that's self-recursive, A contains vectors of A, for instance, or mutually recursive, the struct A contains vectors of B, and each B contains vectors of A, something like this, we need to be able to check that without needing the fully resolved declaration, because otherwise that just doesn't work. I can't, if A contains vectors of A, then to have the definition of A in those vectors, I would need to recursively define A, and just doesn't work. So this layer of indirection is what allows us to have recursive or mutually recursive data structures. So we can't do that. Out of curiosity, I looked at what other languages do as well. C++, which has a lot of inspiration for this, is of course not a good candidate because what C++ do is all of the includes and everything are resolved not as part of the compilation, but there's a pre-processing phase. The include statements are pre-processor statements, which means when you compile a C++ module, you have access to all of the definitions within the module because everything has been inlined. So there's no need to go look other things. It's fine. Everything is there. All the headers are in there. It's fine. But I looked at a more interesting language because I happen to be using a very state-of-the-art modern compiler called GHC, so I looked at what GHC does. And what GHC does is very interesting. It does indeed do the first approach, where it maintains this cache of all of the definitions for all the things that may may occur in the program. And when you compile a module with GHC, it outputs two different files. The .o file, which is like the actual compiled thing that you're going to be able to link afterwards into an actual program, and the interface file that contains all of the definitions required for compiling of other modules. So, in short, we're doing this first approach. We are going to have to maintain a cache of all definitions at the core of our compiler. Every module will therefore have, we will do before compiling the modules, the graph analysis of the different modules. And we will, as a result, build them in order so that we can build a cache that contains all of the required definitions. So as far as doing that work is concerned, that's not going to be something we do this evening. I'm still at the process of I'm compiling one module at a time, so I'm just gonna change it so that my module takes as a argument for the top level analysis function, hey, here's the cache we have already built, assuming that cache will be built basically at a later stage. What we're gonna have to change is just we're gonna have to change the way we think about the cache, and I want to change a few things about the name. Partly because, well, that name thing, the name is ironically extremely bad for this. It is not just something that uniquely identifies the thing, it is at the moment more of a role. This is what that thing is in the scope. For instance, that name refers to a local variable or to a function argument or to a type parameter, not things that are unique within the program. And therefore, as this stated goal of being a unique name that identifies something within the program, it's absolutely terrible. So I want to do a few things this evening. I want to rename what is currently known as declaration as definition, because the declaration contains a definition and it's the definition that's interesting. Currently, declaration is a misnomer. I want to rename this name thing into role and introduce an actual proper name that uniquely identifies things within the program. I want to reduce the monadic structure of the top level of the analysis so that we take indeed from the environment some of the actual table of all of the name to definition. And with all of that, after all of that is done, then we have to just rewrite a bunch of the analysis phase because all of the invariants underneath will have changed. So that's a lot of work, which is why I'm starting a bit early. And yeah, let's get started. Okay, let me first just check that this can just be yes, this can just be reverted. I'm not going to keep this. This was my attempt at changing how the top level is initialized. This is going to have to go anyway as well, so might as well reverse all of it. Check that we still compile. We do. Perfect. And let's get started. So, I'm going to want to change a small thing. This is no longer... I'm going to introduce a new type, which is going to be the name, which is going to be, instead of being this enum of what the thing is, will be basically what I want name to be is when at the end of the compilation phase I build the symbol table. That's the key of the symbol table. That's a symbol name. That's something that uniquely identifies something within the program. But it doesn't have to be like a mangled string like it is in like C++. I think Rust also does name mangling. I mean, we could do name mangling for like debug purposes, but as far as the program is concerned, it doesn't need to be done. It can just be a struct that contains multiple fields rather than just being one big string. And what I want, I think, is I need to uniquely identify something. Since top level identifiers are unique per module, I think what is enough would be the module name. The identifier by which it is known. And we probably want to add arguments, although we'll have to be careful with this, because when we start instantiating functions, there will be a different symbol in the resulting code per version of the function, because they will result in different bytecode and different at the end image, because different functions on with different generic types will end up doing different things based on the size of the types, and therefore they might not have the same bytecode. So the arguments need to be part of this as well. Which is just going to be a simple list of name. Now we can rewrite this as being a role. I probably want generic, so I just can do hashable. And I think I might not want to have role be hashable because a lot of things will not have a definition associated with the role. It's the names that have something associated with it. So I think that's the layer of indirection I'm going to add. Therefore, I think a top level declaration will be uniquely identified by its name, which I think also solves the problem of like built-in things don't necessarily have a definition. Or maybe it just means when I do the resolution from like role to definition, I can do a special case for built-in types, perhaps. So built-in type identifier, built-in function identifier, type parameter, placeholder, none of this changes. Do I want to carry... Yes, I think this makes sense. Keeping in the role the type of the function argument, the type of the variable, I think makes sense. I think we can keep those here. Generic is no longer required, and I think we can get rid of equality and ORD, although that's going to break a lot of things. So that's a first change. Next, what do we have to change next? I want to go back to the AST. It's going to be so many things to change here, but the short thing I meant to change is I think those are no longer... This declaration isn't a good name for it. I think definition is a better name for it. So let me just quickly declaration definition. Okay. Just look at how the module is defined now. Yep. Okay, perfect. That's all good. There's going to be other things broken, but doing things one by one. Now, I want to go back to the analysis monad, I think. Because. Hello! So, let me redo a very short version of the 10 minutes I spent explaining what I was doing. If you remember, on the end of Tuesday, I was stuck with this problem of I have a module A that I'm compiling that imports a function from a module B. That function from module B returns a struct that was imported from module C. But module A does not import module C, so when I'm compiling module A and I get an expression of type struct and I want to check like, oh, accessing a field in it, is that correct? I need to know the definition of that struct, which means I cannot only rely on how I import things in that module to have access to all the definitions. So either I need to maintain a cache of all the definitions of my entire program underneath, or I need to carry the definitions with me in the expressions. For a lot of reasons, the good approach, which happens to also be the one used by GHC, is the first one, which is we maintain a cache of all definitions across the entire compilation, which is what we're going to do. I'm not in its entirety this evening, as in all of the multiple module stuff, incremental compilation, all of this, we'll do when we have actual compilation of a module that we don't actually have yet, but we'll make the code for a module as if the rest of this binary existed, as in take as an argument the current state of the cache and modify that cache with the new definitions that we compute as part of this module, basically. Or maybe return the new definitions of this module in isolation so that they can be added to the cache afterwards. I'll figure that out, but that's basically the gist of it. And I am using this opportunity to do a big rename of a bunch of things that were kind of iffy about in the way I had named things. To start with, I have renamed the name type, which is supposed to be a unique identifier for the things in the program, which it had grown to not be, into role, which is a much better description of what it does. And then name is now a thing that uniquely identifies a thing within the program. It's going to be the keys of the symbol map, basically, at the end. Now, let's redo the analysis monad, which is the small monad in which I run the analysis of a given module in isolation. I think I want to also try to see if I make changes to it, depending on how deep I make changes, do I want to be able to do better in terms of short-circuiting in case of error? At the moment, I am using most of the time a maybe t on top of my monad, which allows me to basically short-circuit to nothing the second something goes wrong, but I almost never use the fact that I can fairly easily recover from it, and maybe that's something that would be worth thinking about, of how do I do something a bit smarter than this? But maybe I haven't given any thought about this before the stream, so I might not do that this evening. It's just something to keep in mind in the background. So, info is the stuff that is in the reader and therefore does not change across the compilation of a module. So here this, well, except for the stack, it does, but that's different. Top level names make sense. That's all of the things that are at the top level, except those are now gonna be. Why would that be a non-empty? Why would that be a non-empty? Why is top level names non-empty? There cannot be more than one. There cannot be more than one name at the top level. Why is that? Why did we do this? Fold with key, yeah. Make paths. Yeah, I just do some basic insert. I don't do any insert with or anything like this. Is it because I do the deduplication of, I do the error? No, I have the error multiple declaration there, which means at the end of this, when I return this, the local names, guaranteed to be unique per... I don't know why I'm doing this. We might as well change it. This is now indeed just the corresponding actual name of the thing at the top level. Although, arguably, we don't even need that, because given the module name, we can already reconstruct. So I guess a list of identifiers would actually be enough. I guess it's easier to maintain the hash map of path to name. That way I don't have to actually do that reconstruction whenever I do a lookup. Okay, so let's keep this. And the locals, that's the local definitions. So to a given name, which now is the correct use of the word name, associates a definition within the module. Could this be merged with this? Or does it make sense to keep them separate? The downside of keeping them separate is like trying to get the past definition of something means doing two lookups, and I have to basically have branches for compiler errors in case we don't have the full mapping, which is never supposed to happen. That feels, yeah, for the local stuff. I think for the local symbols, it might be a lot easier to just put both in the same hash map. Which doesn't mean we don't have to do the lookup in the other one, but it's just going to be easier that way. And I think I'm going to add this, which will be given as an argument to the compiling of a given module as being a copy of the cache that we have from the compilation of other modules before, or extraction from like already compiled modules, so that I can look up definitions for any name in my transitive dependencies, regardless of whether I directly import it or not, which will be, so this is a tuple of name and with location here. And the second hash map will be for a given name, which uniquely identifies something with location definition resolved. Now, I still want to have this exact same thing here, but those are going to be the ones I'm currently building. There's a typo there. And those are going to be instead... I'm not sure I want to keep this context everywhere. That's not great. Is that the result? I guess that's the result. That's basically because the process of the analysis is to transform a definition passed in definition resolved. So I guess that's the result. That's the map to name to definition resolved. Context names makes sense, except this is not going to be roles. As in, within a given scope, what is the role of the thing I'm pointing to, and potentially then its unique name, if there is one. Location hasn't changed, fund type hasn't changed, within loop hasn't changed. Okay. So now when I run the analysis, what will I need? Oh, do I use this opportunity to also change? Yeah, I think I'm going to do that. I'm going to change the way I run the analysis because I don't like the way my top level function is at the moment. And we're going to be rewriting it anyway, so might as well change it. So what I'm going to want to do is do I want to change the maybe T into an except T actually and throw like exceptions bigger quote? Maybe it would be better. That's basically what it is, except I don't have proper support for like, yeah, I'll think about it. Okay, so this will need basically everything that is there. And I guess the easiest thing to do would just be to take the entire analysis info, as in give me the entire thing since it's supposed to be like the same for the entire duration of the analysis. So let's do that. So this will take not the module name, but the full analysis info. And this will be that hasn't changed. Now the analysis info is the argument, so that doesn't need, oh, that means I might want to keep that as a comment because there is the stuff about built-ins, but for now this is basically this, and the context, which we will indeed keep the same. Except, do we need to change anything? Result is an empty hash map, that makes sense. Roles is an empty hash map, that makes sense. Except it will probably be initialized. Yeah, no, this will be initialized as well because there is the top level things that are basically what is the background level of every of the analysis of anything in the module. So that would be a hash map from path to non-empty roles. You can stay there. Initial scope, I suppose. So that's the result starts empty. The roles, I'm gonna call that the scope. That's the scope. That's what it is. Initial scope. Initial location, that makes sense. Unit type, false. Okay. Now, how do I format this so it's readable? I don't know. Okay. None of this here has to change, except maybe reset the state is something that... Oh. Does that mean I need to have the initial scope in my reader as well? I think probably yes. Oh, that's why I had it as a non-empty thing. It's because I was using it as the initial scope. But that doesn't make sense. Does it? Yeah, I think it was wrong anyway. Okay. But I do, I think, want to keep a copy of the initial scope in the reader, because that means then that every time I start... Do I want to do that? If I keep a copy of the initial scope, it means I can just do, rather than doing it at this point, I can do it on the reset state that I do before any analysis of a function or anything anyway. Maybe that makes more sense. So this is going to be top level scope. And that's going to be exactly the same thing as this, but it's not going to change throughout the analysis. I do use local in a few places, which is a bit... It means I'm treating my reader kind of like a state in some way, but it makes some things easier. But as much as possible, this doesn't change, this changes. So that means the initial scope is no longer required. This is also an empty hash map at first. And now in reset state, I can do this. I get the top level scope. The context scope gets reset to the top level scope. And all of the function stuff is as well reset. Okay, there we go. So now that everything has changed, let's go back finally to analysis. Oh, before that, I'm going to keep analysis for last because this is where we have the most work to do. I'm going to go back to parsing and to the parser file. I thought I was free of happy for good, but no, because I have renamed declaration into definition. The constructor names are the same, so this should be a simple replace like this. Like a declaration rule contains a definition. I think this is a better naming like this. Now, let's go back to the analysis and let's go back to this. This function will be what is called by the rest of the compiler when it's time to compile this module into, well, JHC would make it a.o file and an interface file. Here it's going to be mostly the interface file I'm interested in, but basically this thing of, okay, we are going to be taking the module and export both the symbols that we need to keep for further modules for the compilation and the actual like set of things that we want to compile down to bytecode. So I think we need to redo what I had started last time, which was the some module result kind of type that contains everything we want at the end of this. What do we want at the end of this, and especially how do we want to name it? I think resolved module is what I had said last time, and I think it's okay. Because it's a module as input, it's a resolved module as output. Does not shocking to me. So what will we want? We will want, I'm gonna do this quickly so I can have this here so I can look at the things that we have just said we were expecting. We will want hash map from name to with location. So basically the same thing we had here, but better. Which is what, how do we call this? I suppose declarations. Do I call that symbols? I've called that symbols here. That's not really accurate for what symbol is usually used for, because this is definitions, not... Yeah, I think this needs to be definitions. Not symbols. Okay, so I'm just going to say res. I think there's nothing else that would use this prefix. So that's the declarations that are the result of this, which is basically our context result. That's basically it. What else will we want? We are going to want the actual symbol map, I think. Do we? I think we do. We need to have, in the logic that I've been using, which is the C++-like logic, basically a generic function is not instantiated until it's actually, until some function actually calls it, gives a type argument, and therefore we can do the type checking, and we can instantiate the function and check and like create a new function, which is the resolved version of it. Do I simply include this in the res declarations here? Is that enough to have as well for each unique name the corresponding declaration. I think it actually might be. It's just that if I instantiate something, then I will add it to my cache. And I can have at the top level, when I merge the cache of previous modules with the cache of this module, in case of collision, because a template function was instantiated more than once, I just check that they're the same, and therefore that there is not any issue there, and I just keep one of them. They're deduplicated. But that way, each module contains the full definition of everything. Yeah, I think that's the right approach. So that means basically that I don't really need this resolved module. The only thing I need is to return that is this hash map from name to. I don't think there's anything else I need. Unless because I am currently using another monad on top here. So I have two layers. It's weird. I don't like this. Maybe instead what I do is I bundle the diagnostics with this. Basically, here are the errors I have encountered while doing this. Yeah, maybe that's better. So basically, I am making this type here, but I'm making it another data structure instead. So this would be diagnostics, which is just a list of diagnostics. As a result of this, which this is a maybe, because if any of them failed to compile, then we don't return a list of symbols, we just return the list of diagnostics. But this both might be true at the same time, because we could have only warnings here and therefore a value here. I guess I could use data these for this. Because that's basically what it is. I can have a result without, yeah, I can have a look. It's called again. Yeah, data these. I think that's what I want. So resolve the module, I'm just make it a type alias for now as a result. This is going to be these. And this is the hash map. And that is the diagnostic. Okay. Oh, this is not even returning anything in the monad, interestingly. Except now this requires more than this symbols thing. It requires almost the same thing. I'm gonna make a type alias for it. That's gonna be named definitions, I suppose. Name definitions is this. Or maybe definition cache. Maybe it's a better name. Definition cache. Okay. So this requires as an argument the definition cache. Does this require as well? Because I need to be able to look at a given module's stuff as well. Specifically because I want to be able to know how to filter my use statements. What did they used to have for this? Just the symbols. Oh, but I had a mapping from a module name to the identifiers and thing within it. Okay. How do I want to do this? Do I want to have my definition cache and a second cache, which is for a module then? Because I need to know the identifiers as well. Maybe after all, I want to store different. Maybe, in fact, I just want. Yeah, okay. Let's go back to what I was suggesting before. Let's remove this. Resolved module. And the resolved module will contain the local definitions, which is going to be the hash map from identifier to declaration resolved. Definition resolved, actually. Let's change that. It's going to contain the new entries for the cache. Which is this hash map from name to definition resolved. Which this is supposed to be basically the same thing, but with the identifier and name, and that way I don't have to recreate one from the other because it's going to be trivial to do that at this point and more complicated to do it from the outside. It's a bit ugly. That means I'm gonna keep two copies of each definition, basically. It's gonna be like, oh, for this module, here are the things that are in scope, and for the unique names, this is where the cache is. It's not the end of the world. It feels slightly redundant, is the only thing. Oh well, I think that's fine. So that's going to be the definition cache. I'm going to use the same alias I have defined here. And I think I want to also have an alias for this, which is basically within a module. And I guess this could be the local definitions. Because the use of identifier implies that this is relative to something and therefore local to a module. Or relative definitions? Makes more sense. Yes. Okay. And this is and also I think I'm gonna make it the relative ones which are used for imports and therefore for maybe I want to keep the location in both. Because I will have to do lookups for this type checking anyway, so yes, I want to have both. Okay. So I will be returning at the end of every function, of every analysis, the relative definitions and the definition cache. And I think as a result here, what I'm taking as argument is the definition cache, but also a hash map from module name to relative definitions. There we go. So at the end of this, the cache will be merged with the global cache, but the definitions will be added to a hash map for the module so I can extract things from dependencies. Module name, module, and then the result will be... Is there something there that says... I don't think, because like either the left one is usually the error, the right one the result, because it is a functor over the right one. I don't know if these has anything like this in terms of convention. I would be surprised. So I don't think I'm just gonna say, but in the spirit of usually that's how it's used, I'm gonna, for either, I'm gonna do this resolved module. Okay. So now this is our definition. We are going to need to rewrite this function and a bunch of others to make use of that. Because we are going to do the run reader here. That means, actually, do I need to change any of this, or will the monad still be the same? No, I'll have the local definitions. That's fine. Yeah, okay. But do I want to change run analysis at all? Nah, it just takes the entire. Okay. So I'm gonna put this here actually and shrink it a bit. So I just need to keep this in scope. In this function, we're gonna do two things. The first is we're gonna be building the analysis info, which is our reader context for the analysis of this module, based on the extraction of use statements from the module, which is code I didn't want to touch because it was complicated, but we're gonna simplify because none of the definitions will be taken from that anymore, which is gonna be a bit easier. Actually, yeah, we don't need to take the definitions at all anymore. Wait, yeah, I can simplify this further. Since the definitions of foreign things will all be in the cache, I don't need to return the local definitions at all. The only thing I need from a given module is the list of the names it exports, basically. I don't need the associated definition. I will not be using them directly from the names. So that means I can simplify this further. What is exported from a module is basically a list of identifiers, and that's it. The definition cache will take care of everything else. So, as a result, that's just a list of identifier per module. So that's basically when I do a use statement, here's the list of things I could be importing from this module. Okay. So, definitions cache, top level definitions, this name, this module, and then we are gonna change a bunch of things. None of this is gonna stay. What we know is that at the end of this, when I do a run analysis, where are you, run analysis? You're right there. I'll get diagnostic and the thing here. Do I actually want to do the same thing and do these at this point? Maybe that makes more sense. Maybe I should do that, yeah. Yeah, I think I'm gonna do that. So that just means, okay, let's move this away for a second. And that means I'm just going to, these is not a monad, right? I can't do a do block. Yeah, I can't do that. It is a functor though. So I think I'm correct in using the, wait, if it's a functor, is there, oh, there's no applicative, no, there is an applicative instance. There is a monad, okay. So I can do a do block in this. The problem is I can only, yes, I mean, I need to have something that returns something that is already a these, which is not guaranteed, so I think this is pointless. What I need to do is basically, oops, this eval RWS thing, given an action, given the info, given the basic context. Can I actually, yeah, I'm gonna make something here. Um, the initial context for is just an analysis context with everything initialized by default. An initial context is an analysis context. I'm just gonna copy paste it, which is this thing. There we go. Initial context. Okay, that gives us a tuple of A and diagnostic. And I'm just gonna make that to a case. And actually, how did I do that already in the analysis? Oh, I have the run maybe t thing. So I can't do that here, I suppose. Unless I make it so... I don't think I want to make run analysis do anything else. I think I don't want to do that. Therefore, I'm going to revert this. This is going to go back to being this, and therefore this is just a swap. Okay. That means if we go back here, this top part of the declaration of the definition of the function will be about initializing the analysis info, the reader context thing. At some point, we will have it. And what we will do in the end with this will be how did I do the maybe t here? I don't seem to be doing a run. Oh, because I had the run maybe t at the top, of course. Yes. So here, what I want to do will be that doesn't make sense to have had the run maybe t at each level like this, does it? Oh, but I was doing a run maybe T there, and I had this one because I only had this one. I don't need to do that. So instead, let me think. I'm back to this idea of how do I signal that something went wrong, despite the fact that, like, at the moment I'm not doing anything like this, I think. Or was I? I was doing a run analysis, so I would get the diagnostic, yeah. But I'm not doing that anymore, so I have to think for a bit about how I structure this. Because if I do a maybe t, then the value is lost. So I think this is going to be at the end. I'm going to do a run maybe t of whatever ends up being the rest of the code. On this, I will be I'll do a run analysis, which takes, as we have established, just the analysis info. With whatever comes after here. And at the end of this, I'll be able to do a case of the result. And actually, I can already unwrap this. This is going to be diagnostics and result. Can I make it a non-empty list? As in, do I want to use these actually? Does that make sense? Or do I just want to say, no, this is just what I had before, which was better, which is list of diagnostic and maybe the result module. Yeah, maybe I was right about this. Maybe this is easier. In which case, there is no need for me to do a case or anything and transform anything. The result will simply be run analysis of analysis info of run maybt of whatever we end up doing in the main block of this function, which will be, I don't like the way this is aligned. Can I align it differently if I do this? It's still ugly. Okay. And now for mode declaration. Okay. Why do I keep actually the local definitions? No, that makes sense. Okay. Do I want this to be name, actually? I think I want this to be name. Because I need to be able... Wait, no, I have it here ready. But don't I want to have... Yeah, no, I think this is wrong. I think I just need the exact same thing, which is this. Okay. So, for each declaration within the module, run maybe t. So this, the whole thing needs to be a maybe at the end. I don't even need to do actually maybe. I can just do... I do this, which means I get the symbol For each declaration, I only get the symbol if the analysis runs successfully, which I think is what we want. Unless, again, I switch from maybe to something else that is better for reporting errors. Still thinking about that. Like, when do I bail out of the compilation of a function? Because if I bail on the first error, maybe there's a bunch of other errors I'm gonna miss. I don't know. TBD. So let's change this. The name of the declaration will be a name with this name identifier and an empty list for now, because the list of arguments will be given for instantiation of functions. Oh, do I want to export enum values here as well? I suppose, yeah, that's gonna be part of the identifiers in scope. Yeah, okay. I'll have to export the modules as well, the enums as well. So that stays. But I probably will want to not do that here then, because what the name of what's exported will depend on what I am doing. Because for an enum, for instance, I will be getting more than one name to export and more than one identifier. Yeah, okay. So I'm gonna change this. Which means I am not going to give it its own name. Oh, but I have to. I have to, because I have to be able to detect. I have to be able to detect loops. But I guess I can let each declaration do that on its own rather than doing it at this level, I suppose. Like, for a given declaration within the scope, give me the actual definition and find the resolve the loops yourself rather than giving it the name. I think that makes more sense. Okay, a nice declaration just takes the declaration. Why not? Except now, this is gonna give me instead. This is gonna give me things will be added to the cache by each definition. So each definition will be added to the cache. So I don't need to collect them as a result of this. So the only thing I need out of this is the list of identifiers for which I only need the list of identifiers that need to be exported out of this, assuming that for each of them, something has been added to the result cache. Yeah? That just means I need to be careful about the fact that each declaration needs to give me a list of identifiers and add things to the cache itself rather than trusting me with putting them to the cache. But that makes sense because analyze declaration is where I maintain the cache in the first place, so I think that's okay, even though it's like splitting the responsibility in two places, which I don't like that much, but I think that's fine. So that's going to be exported identifiers, which will contain the enum values at some point. Okay, so that gives me for each... I can probably do this differently, although that works, I suppose. That gives me a list of the maybe list of identifiers. Then if I sequence that, I get a maybe list of lists, which will be nothing if any of them fail, which is what I want. And I can just concat that. And that gives me my list of exported things. And I can get the cache by getting it from the context, which is our context result. Or I guess context cache, because I'm also going to be using as a local cache for things. So that's the context cache. And at the end, we return. In the case where we do have something, let me think for a second. I can probably do this as a block, a do block in the maybe monad, because this is gonna be... I'm gonna do this, which will only give me something if there was no nothing in there, which means if there was nothing in there, this short circuits to nothing, which is what I want. Otherwise, if it was nothing, then I can get... I need to do that before because it needs to be done in the context of the monad there. And should this work, then I can return here. I can probably do that differently. Yeah, I can probably do that as a map on the sequence exports. Yeah, it's almost cleaner to do it as a like this, and I return pure of a resolved module that contains all of my exports and the cached definitions. Okay, so that's what the end of the function will be. Combined maps might not be needed, we'll see. But this will depend now on being able to build the analysis info, which is currently missing. Again, it's going to set this here. Perfect. So we're going to want to build an analysis info, which will contain the module name, this name that we have here as an argument, that will contain the info stack, which is a hash set, which we use as a makeshift deduplication thing to avoid, to detect loops. It's kind of ugly, but it works. And I think this started empty. I'm gonna copy paste this here now, just to have it in scope here. Yeah, this started as empty, unsurprisingly. Um, Now, this is not going to be the same because this was the list of built-ins, because the built-ins are always in scope. But this will be used for the top level scope right there, which is the path to roll, which we're going to need to build based on the use statements. So, the local definitions, which are going to be part of this, which are going to be this thing, is going to be a hash map obtain by going over for each declaration in the list of declarations of the current module, get the identifier name. I think that's... Is that correct for enums as well? No, I will need to put that in scope as well. Which means, actually... I don't need to construct this list of exports here. I can build it from the get-go. Okay, yeah, let's do that. Let's do that. This is a bit of a mess. Sorry, it's gonna become a bit more readable as we make progress. Because this is going to be what we export from the module is basically everything that is a top level, because at the moment there is no public, private visibility, anything like this. And it happens to be a list of identifiers. Yeah, which is just map definition identifier. Oh, did I change the name of that function when we did rename to definition earlier? No, it's still named declaration here. Okay. So map definition identifier on the definition of the module. Oh, except this should be named definitions. I guess no. I guess in the context of a module, it makes sense for them to be declarations because they associate a definition to a name. So I guess in module, I'm going to keep them as declarations. So I will get the identifier. That's my list of exports. Okay. From that, oh, that's not true. That's not true. I want to make that another function because I want... Which means I'm probably going to remove this function from here because it is not reliable. And I think I am going to make it... I'm going to put it, I don't know, here. Which instead gives me a list of identifiers, which will tell me what to export, what to put in the scope, which for a constant is easy. All of them is easy. The only thing that is not is the enum. And for an enum, it's going to be several things. It's going to be the enum name. at the beginning of a list. So all of these others are going to be a single list, a list of one element. And for the enum name, this will be, and actually this is going to be on a definition past. I don't think I want to support this anywhere else. I want to make this, since this function is a bit tricky compared to how it used to be, I want to make sure I don't do it wrong. And will also contain the enum info, which I don't remember how it's called. Enum name, enum values. Okay. These are the identifiers to put at the top level, and that will be exported from this module. Because I'm not doing the Rust thing where like the identifiers are qualified by the type name. They're going to be at the module name, at the module level. Okay. With this, I can say that my export is just map definition identifiers of the module declarations. Perfect. That will be the value here, the exported stuff. But that also means that for the local definitions, I probably want to do this. Yeah, I'm going to do it separately rather than trying to do it in one go. Local definitions is going to be a simple hash map there again. So a map from list where I'm going to also again go for each declaration or definition in the module declarations. And I'm going to get the identifier in the definition identifiers again of that definition, which is why it bothers me a tiny bit and doing the same thing twice. But here I want the concat map actually, and here I want to instead build a very specific hash map, because now that I have this, the name that will be for the local definition will be, well, yes, it is the name. It is the name with this name, the module name, the identifier, and no arguments. So that's the key, and the value will be the definition. So that's the local definitions, which will be this part of the analysis info. Foreign definitions will be basically the definition cache, because that's what it is, yeah. To the point that I wonder if I want to reuse this type here, maybe not, it's fine. Okay. And the top level scope, which will be the hash map from path to non-empty roles. That's the difficult part. This is what I used to have as here, this init local names. Because this is where it gets tricky. This is where I have to realize whether I have conflicts or not. Do I want, because I'm gonna do the same traversal again. I'm gonna go over the declarations and I'm gonna do the same thing again. Do I want to try to see if I can bundle all three of them into the same thing and do the traversal only once? I think that doesn't make a lot of sense. I just need to have a function that checks it once, I think, because the others are trivial. The other things are absolutely trivial. Like this is just going through the hash map. There's no difficulty there. The only thing is like neither of those is valid if there is a conflict in the name. So I guess yeah, I'm just gonna keep it as separate functions just for the simplicity of it, which means I'm gonna keep this init imported init local context, init local names, which is going to actually now create local scope as which is a better name. Which gets the list of declarations. And how do I want to do this? Because I would like to avoid having to do more monadic layers where it's not needed. I think I can just make it return what I want, which is list of diagnostic, maybe local definitions, which is this hash map name here thing. As a pair, there we go. Wait, no, that's incorrect. This is this thing I want to create. So path to non-empty roles. Is that the correct amount of parentheses? Yes. Actually, do I want to allow things that conflict with reserved identifiers? No, I should probably not allow that. But I think that's checked. Do I check? I don't want to add more things to the stack of things I'm doing already. Do I check when I do an analyze constant? No, I don't check the name. I don't check that the names are not. So maybe I do this as part of this then? Like none of the names are reserved. Maybe that makes sense. Because I have the is reserved, right? Yes. But I don't use it. Oh no, I do it here. Perfect. In analyze declaration. Okay. So I don't need to do it at this point. It's fine when I create the local scope. That being said, if I do it at that point, then I never run the problem. I don't have to decide how I want to deal with the fact that like there might be. So maybe, but the downside is the sooner I stop the compilation and the fewer errors I report to the user. If I stop at the top level because like, hey, one of the names in this module is invalid, then I'm not reporting any of the errors within the declaration that are valid because I have short-circuited before. So maybe saying, hey, I can't analyze this declaration because it is shadowing a built-in maybe makes more sense. And that will mean I will keep the built-ins over the local ones if there is a conflict. Okay. So I can go back to what I was doing since I'm okay with this solution. I was doing create local scope. There we go. Well, That's not entirely true. The local scope will be a union of the foreign scope, and I guess local scope is not wrong. But it's not the same thing as the top level scope. I need to be careful. So I will need, since I'm not going to do that in a specific monad, I will need the module name as well. Which I'm actually going to make the first argument. So I don't have to do that. And this is going to be a run maybe t, because I believe that tuple like this has a writer instance. Let me check. I want the class. I want another writer. There we go. Yeah, there we go. If the thing W is a monoid, there is a monad writer instance for tuple with W as the first argument. Lists are monoid. This is therefore a writer, so I can use the thing I wanted. And with a maybe here, so I can do a run maybe t. Perfect. So now I can keep more or less the same thing. Except here, I'm not dealing with roles. I am dealing, well, I am dealing with names because the role will be a name that happens to be, well, a top level declaration with a name. So that's, but still, I'm gonna say that's a role. Except here again, I'm gonna need to, yeah, be careful. So there again, I'm gonna do identifiers. I'm gonna copy what I've done up there. For each definition here, I'm gonna, in the declarations, for each identifier in them, I will want each constant in to have its own name and then have a mapping from that name. So I want to be able to distinguish. Because I think if I say that the enum type and the enum values have the same name, what does that mean? Do I say that they have, well, if they have the same name, as in their role is top level definition with a name, and if it's the same for all of them, what does that change? No, I think they need to be different. I think they need to be different. But I will probably want to be able to distinguish between. But I guess that's easy. Is the name of the thing the same as the type name, or is it not? Which is what I was doing before, I think. So I think, as a result, this is fine. I have the identifier, I have the definition. The name is a name with the module name, the identifier, and no arguments. The role is top level declaration with the name and the, well, the declaration is not there. That's just what it is. Because I don't need the declaration anymore at this point. And so I return something grouped by identifier. So I am able to then deduplicate based on whether an identifier appears more than once. So that means the result of this is a simple tuple of, and I don't need to combine locations because I don't need the declarations the declaration for this, which means their locations don't matter. Let me just check something real quick in here. Yes, I'm doing the same thing here. This makes sense. Okay. I guess I could build all of them at the same time. The exports, I could do all of that here at the same time by building three by building a list of 3 tuples, which means I get a list, well, a tuple of 3 values, which is the key value pair for each of them. And then I do an unzip on the thing to concatenate to get the list of all the first values, second values, third value, and then I get the hash map or list for each of them. That's doable. It avoids duplication. Yeah, let's do that maybe. So this means here I will return, wrong function, here, if this whole thing works, I will be returning exports and local definitions. So that would be a maybe of, God, it's going to be a nightmare to write. This is going to be the export, which is a list of identifier. It's going to be the local definitions, which is a hash map, which is this thing. And it's going to be the hash map from path to non-empty roles. Unless I decide that this is too complicated to do at this level. The upside of grouping all of them here is that the name transformations and the checking all happen for this. Like, I can't create any of them without doing any checks. The downside is this function becomes a lot more complicated because this loop here ends up creating 3 different values. Then I do have to do the hash map for the duplication, and then I do an unzip 3 to get the 3 separate lists to then combine them into their own things. I still think it's better to do it once in one place. So I'm still gonna do that. Except this is ugly as all hell, so maybe let's make that a bit more readable. There we go. And I can use the list of identifier for this. Okay. So this is going to be a from list with plus plus, I suppose. Because I will want, for each identifier, I will want its name and its declaration. And I think from that, I am able to build everything. Role, name, and declaration. I can build the list of exports, which is a list of identifier. I can build, yeah. So I have the name, I have the role, I have the definition. This returns a key value pair. Oops. In which the key is the identifier. and the value is a list, so I can concatenate things because I want to check the unicity of everything. And each of them will contain a path. Well, the path will be... No, it will be created later. I only need the role and the name. Oh, and the declaration, a definition. Okay. Or do I want to make the map already? Because if I do the map already, I don't have to do a complicated retraversal again. So maybe I immediately build... So here, this will be... The key will be the name and the value, because it's going to be this hash map here. So it is a key value where this is the name and this is the definition. And this one will be the list of path to role. So what are the paths? Let's scroll down for this. What have I been doing for paths? I have this make paths function, which is identifier and module name plus identifier. That makes sense? So the two paths are pure of the identifier and module name pure identifier. Those are the two valid paths by which a thing may be referred to in the current module. Because if I have a thing named foo, a function named foo in my current module, I can call it by just foo or by module : foo, as in a fully qualified name. So both those names have to be in the scope. I don't do partial names like super something or anything like this. So either you use the full qualified name or the local name. That's it. That's the only names. And as a result, I just like do a full hash map of all the names to thing. I don't do like path analysis to try to find something a bit smarter than this. So all those are the two paths by which a thing in the local scope might be referred to as, and that means I'm returning the role. I don't need the role anymore. The two things I need to return as part of this are the things I'm going to need to create this hash map and this hash map. So that's name definition, which is a key value for the first hash map. And for the second hash map, it's going to be a list, which is going to be map role to the paths. There we go. And I return a list of those two things for each identifier. So that I can then do a from list with plus plus, so that I will detect if there is more than one entry per identifier. Okay. Perfect. This can go away. I'm missing the do block here. There we go. Report an error if any identifier appears more than once. I want the location. I can add this here, I suppose, as a first element of the tuple. Or I could just look at it from as being the second element of the first element of the tuple. It's already there. It's a bit ugly, but that's not the end of the world. So I am transforming my list of top level names in hash map into a list. I get identifier here, and I get a bunch of other things. Yeah, I'm not going to do more than one traversal at this point. That's fine. So I can already unpack this. I don't care about the second argument. I care only about the first one, because here the second argument is the definition. Okay. Now, actually, it's even simpler. I can do... I can make it a non-empty list, actually, because that way I can guarantee that there's always... I can guarantee that there's always something in there. And this is no longer plus plus because it's on list. On non-empty list, I'm going to just use the union. Okay. So here, what I want to know is the entries that I've got for an identifier, and there should be only one. It's an empty list, so it can't be 0, so I can always extract information out of it. But basically, has duplicates is a number of entries greater than 1. When has duplicate, tell, and that's putting an error in the list of diagnostic. Perfect. With the identifier. And what I'm going to need here is I'm going to need the list of locations. So I'm able to say, hey, it declared twice at this place and at this place. And that's going to be... Actually, I'm going to do it this way. Locations is going to be for each tuple of things that has a first thing in which the second is a location, is a definition in toList of the entries, because I'm going to want a list for this. Actually, do I want a list for this? Wait. Error multiple declaration, not duplicate. Multiple declaration. It's a non-empty list of location. I don't need to convert to list. This is a much simpler entries in which I do a hash map of a f map of, for this tuple of things that I know are in it, I want the definition. And in fact, I want the location of the definition. Okay. Has duplicate is the list of locations is greater than 1. When has duplicate, put an error in the writer monad. Return true. This is collected as an OR. If any of them is false, this is failed. When failed, short circuit. And now that it is done, I have my top level names. I am guaranteed that the non-empty list is unique for each of them. So now, what I want to do is The export is just the list of the keys in the thing. And now I'm gonna want to build the list of all the things, which is going to be the first one on the left-hand side is the local definitions. The one on the right is the local roles, local scope, I suppose. And this is obtained by doing an unzip of, it's not toList, I want the values of the hash map. So it gives me a list of those non-empty list of tuple of things. So I want to make that one element per thing because it's guaranteed. So I can map that to head because it's guaranteed to have at least one element because it's an non-empty list, and I have just checked that there's no duplicates, so I know it's exactly one. So I get this list of the values of my hash map. I do the non-empty head, I get one element per thing, and I unzip that, which means this is now a list of those key values. This is now a list of those list key values, which means I can finally return. I can get rid of this again. I can return the three things we need, which is the export. For the local definition, this is purely a hash map from list of those local definitions. And for the local scope, this is a hash map from list of concat of the local scope, because there is a list, there is more than one entry per thing they had. Okay. Okay. Perfect. That creates local scope, gives me all of that. So I can go back here. And I think I'm going to do the exact same thing I've been doing for the other function. I'm going to use the fact that the writer exists in this, and that, yeah, I'm going to just do a run maybe t over the writer monad that is a tuple, which means I can do the same thing here. I think because it gives me do I want to return this as a maybe t of, do I want to not do, yeah, perhaps actually, maybe it makes more sense. Maybe it makes more sense. So that would become for some monad writer of a list of diagnostic M, this result is a maybe T of M of this nonsense, which means I can remove this and keep this. There we go. Which means I remove the run maybe T here, because I am always in the maybe TM. That's fine. So I can do the same failed M0 here. The tail are still working. Okay, so that should be fine. That means that here at the top level, I can do exported local definitions and local scope all obtain by doing a create local scope of this name and the mod declarations. Okay. Now that it's done, I'm gonna have to do importing the. So I can just move this away. That's done now. So this immediately fails and short circuit if there is duplicate declarations, but otherwise we create all three of those things. Actually, this, now that I'm in a nomadic context, this in is no longer required. I can move this a tiny bit. I'm gonna put this here. Because now I already have the module name, the stack is empty, local definitions, and I'm missing foreign definitions and top level scope. The top level scope will be obtained by combining built-ins, foreign scope, and local scope. But they're not going to be combined. I was going to say not combined. No, I think there's going to be a union of, like, it's fine. It's fine for something in the local scope to. What's my policy on name collision? If I have a name in my local definitions that overrides the name of an import, I'm import module B that declares a function print, and in my module A, I declare a function print. If I do print in this module, should it always be understood to mean the one of my current module, or could it conceivably be meant to understood any of them and therefore be ambiguous? What does Rust do? I have a function bar here in this top level module. I have a private-ish module here that uses super bar, so it is in scope, and I declare another bar here. Actually, this is going to be Baz, perfect. And I do another bar here. Something like that. It conflicts. It's not allowing it. I cannot redefine something that has the same name as something of one of the imports. Okay. Okay. That is a tiny bit annoying. Because if I want to do the same, maybe I don't want to do the same. But if I want to do the same, it means I have to not only do that duplication I'm already doing, I have to then also check that none of them appear in the foreign scope. In fact, does this in Rust short circuit any analysis? For instance, here I'm going to make this print function wrong. Expects an argument, none is given. Does this thing short circuit the thing and therefore stop the compilation, and I don't get the error message here, or do I get it? I do get it. Okay. So maybe that's an error at the. No, actually. Huh. Because I can't really do that in my case. I guess I could always still run the analysis on everything, even if the names are wrong. Because I could say like, okay, this list of names is wrong. I can't do anything with it. But then decide I can still do the analysis on everything, just running with a wrong scope. Do I want to do that? Or do I want to not run the analysis with a context that I can't guarantee is correct? It's a good question. I think I'm fine with functions being the same across modules. I think I'm fine with that. That just means that if I define a function in my local module that has the same as an other imported one, local use will have to be qualified. It's not the end of the world. I think I'm okay with that. Okay. So I'm not going to do the same as Rust for simplicity mostly. Okay. So what I need next is I'm gonna need foreign definitions and foreign scope, which is gonna be obtained. See, this is another example of like I probably want to do something different. I probably don't want to short circuit if I probably want to instead I will probably want to instead of using maybe T like I'm doing at the moment, I will probably want to have some kind of more complex monad thing where I am able to accumulate errors as much as I want, and every now and then I'd be like, okay, if there has been an error so far, short circuit now, basically. That's probably what I want, what I will want, rather than doing this where like those errors that appear here will short circuit, the errors that appear here will short circuit with just a maybe T. And in fact, I could collect all of those errors before actually short circuiting. I guess I could just use the maybe T, but I could use the maybe T, but not short circuit all the time. I'll do that later. I think this is the kind of change we can do when everything works, and we're so far from having everything working. One problem at a time. I think it's fine at the moment if we short circuit too quickly. Okay, so create foreign scope. Probably gonna not need this name, but it will probably require maybe it will require this name, but it will definitely require the module imports. And it will require the definition cache. Wait, what's the... Oh, yes, and top level definitions as well. The module definitions. Well, exported list module exports. Module exports. Okay. So this is going to need the create foreign scope is going to require the definitions cache. No, it's not. Because I'm creating the scope. The foreign definitions is just the definition cache. I don't need to do anything with it, so that's just the original definitions cache, which I can rename foreign definitions then. Now, the only thing I need to do is create the foreign scope, which will give me this. So that's going to be a lot easier. I don't need the foreign definitions. I need the module exports. And I need Why would I want... I think I only need the module imports, which means I can probably remove this name instead of this name. Okay. And if that's correct, then after this, I'll have analysis info module name, empty stack, local definitions, foreign definitions. I will be missing one thing, which is the top level scope, which is going to be a fold L prime of... How do I want to do it this way? Because there's... Wait, let me check. Hash map strict. Oh, I have the Rust one before the Haskell one nowadays. Is there a unions with? There isn't. There's unions. Let me zoom this. There's unions that take a list of hash maps and does the union of all of them, but I want a union with that does not just... Oh wait, actually no, union is fine here. Because... No, union, I think by default, yes, if a key occurs in both maps, the mapping from the first will be mapping the result. I want to combine the values, so I want a union with, so I would like a unions with, which doesn't exist, so I have to do it myself. So this is gonna be... I could do it as two unions manually. Yeah, I used to have, I think... Yeah, there we go. It's still there. Just gonna bring this back up. Combine maps. So this is gonna be... I'm gonna need to make a map for the built-in things. Let me quickly check. Because what I want is path to role. And I have path to name, which is not correct anymore. Will my path info need to be a role or a name? It will need to be a role, right? Yeah. Because the type will be pointing. It depends. Will some things be roles? Will some things be names? Like in the type of something, in the path info, will it need to be name? Will it need to be role? I think it will need to be name. There are so many things that are going to be broken. There's so many things going to have to change. For built-ins, for now, I think I want the role because the name is not... There is no name for built-ins. There is no unique identifier for built-ins. That's why they don't have declarations. So maybe I want the role. But I will want the name at some point, I think. The problem will be that I will not be able to get a name for the built-ins. Unless I change this and I associate a name with... Because I will want a name to uniquely identify the types. Because the role will tell me what that thing is in the moment, but built-in type, built-in function, what that just tells me that this is a special type, special function that don't have a definition. But I still need a name for them. I still need to be able to say the type of this is this unique thing that happens to be this name. So I will need to have a name for this. So that means I probably just need a name there. Yeah, I think that's all I need. And I suppose that means, since the module name is a non-empty list of identifier, I am going to need to have to reserve a special module name that can't be used. Or that means the module name is actually a list, and the only case of it being empty is for built-in stuff. Yeah, I think that's better. That's my break. So many things everywhere. Because everywhere else, module name is assumed to be a non-empty list. So maybe actually I keep module name as a non-empty list, but as far as this thing is concerned, that's a list. Or maybe what I do is I'm saying this is a non-empty list of identifiers, the last of which will be the unique identifier. Yeah, there we go. And it's only going to be one value for built-ins that will not have any prefix to them. There we go. So, do I need to do role here? I think I might. I still want. I think I want this to be the role, because that's what I need to initiate my scope. But I think those patterns, I will want to have the name here. So that means I think let me think for a second. Because here I'm using the path name of the int type, which would be a name, not a role. So I think what I want to do instead is I want to define a bunch of, I want to define those things as being the role of the path name, which means the role is built in type, where the name is the first argument, the path name of this thing, which hasn't changed. All of those things are the same. The difference is now those are no longer roles because they're here. Those are actually names. Placeholder doesn't have a name. That's a problem. What's the name of a placeholder? Because I will want to be able, yeah, since I wouldn't have roles. Is that correct? No, actually, I think that's not correct. I think I will want to have roles in my types because I will want to be able to say that the type of something is what is the role actually, not the unique name. So no, I think all of those need to be matching with the roles. That means I can remove this, that's fine. Which means I probably don't have to worry about the name of the built-ins, because they're not gonna be... I think I still will need to worry about them for some things, like built-in functions will need to have a name because they will be included in the symbol table. But types might not need to worry about names, maybe for built-in type. Maybe the identifier is enough? Which means we're back to basically this. I'm calling it type because it's a path info. Okay. I think that's all correct. That's the role for each of them. Yeah, okay. I think that's correct. I will just make immediately one change because otherwise it's going to be a nightmare. When I try to compile anything, I need to say that the type of a name type resolved is a role. Which is not great as a name type. It's fine. It's fine. Naming is hard. That's the most difficult part of all of this. But as a result, basically the only thing we've changed here is role from a name. Everything else is the same. That means if I go back to here, then my top level scope, first I can do built-in scope, which is I do a for each identifier role in the list of built-ins called built-ins, which might not be imported here. It is imported here. Perfect. It is a hash map from identifier to pure role, which I guess I can rewrite as being map of fmap pure of the built-ins. There we go. And now the top level scope is the built-in scope combine maps with the local scope combine maps with the foreign scope, which I could write as a fold, but I think this is clear enough. And now we have module name, empty set, local definition, foreign definitions, top level scope. We have the analysis info. We can do a run analysis of the analysis info, and then for each declaration, I don't need to collect the exports anymore. That's fine. And each of those things will populate the cache of the result, this context cache for everything it does anyway. So I don't need to collect anything. This is now purely a traverse analyze declaration of the mod declarations. The only thing is, that's the only downside, is I'm going to be recreating, the name creation will be redone within analyze. That's fine, I think. Okay. Then after I'm done with this traverse, I get the cache definitions, and I do this very simple. Get all of the exports, which I don't need to do anymore. I don't need to do that. Oh, but I need to know if any of them... Okay, so because I want to not short circuit if any of them fails, because I want to analyze all of them before I collect the results. What that means is I probably want to do something a tiny bit smarter, which means I probably want to do the same thing I do in the other thing. Failed is, and that's just because I don't have a better way of being like, oh, did any of them fail short circuit? That's fine, which is gonna be a for mod declarations, which gives me a declarations. I do a this actually just really gives me nothing, so it's just so I just do it's just a is just of run maybe t of this. So I unpack the maybe t, I get the underlying value, which is unit I don't care about in a maybe. So I get a maybe value in my underlying monad, and I do an is just, which means I get a monadic value of a boolean, and I will want success being the end of this, unless success m0, short circuit if any of them failed, which means this overall monad needs to be maybe t, which means I need to do here a maybe t of do. Wait, no. I am already. Yeah, this doesn't work. I have the problem of I need to make sure. Ah, this is tricky. Okay. Because at the end of this run analysis, I will get the diagnostics only if. So at the end of this, I will get my diagnostics resolved module out of this thing, which is not in maybe t, and that's crucial because I unwrap from maybe t there. Which means I will need to do a tell diagnostics, and then I will need to, like, I think it's not called hoist maybe, but something like this. I think it's just maybe t. I will get a value. Well, maybe not. There's something else. Isn't there a hoist maybe or something? Hoist maybe. There we go. Let's zoom this a bit. Hoist maybe will be the end here. Hoist maybe of the resolved module. And actually, I'm going to do this in a let because I don't want to do this on top of another monad. That's not what we're doing here. And now I need to decide how do I identify that all of them gave me something. I run this in maybe T, so I will collect if I for each declaration I do a run maybe T, which is I can rewrite this is a traverse of run maybe T dot analyze declaration of the mod declarations. There we go. That gives me a list of maybe values in my monad. I don't need to do that anymore. I can get that list and I can get a single maybe value by doing a sequence on it. And now this thing is a maybe whatever, it's a maybe list of unit or something like this. It's just if all of them succeeded, it's nothing if any of them failed, which means I just need to return the resolved module in a maybe, if that thing is maybe, which I can do with something like this. I just need to triple check. I never remember which of those operators is which direction. If I look at this one, the values on the left, the functors on the right, and it overrides. That's the correct one, perfect. So I'm putting this thing into the maybe value here, only if that's, I guess I could just do a maybe T on top. No, because I want to run all of them first. I want to do run maybe T. Yeah, okay, this is a bit ugly, but this will work. Okay, so this is a bit more concise as this was earlier, but we are still missing one thing, which is we need create foreign scope, which will be easier than the local scope, which is good. It takes the module exports, which is the hash map from module name to a list of identifiers, and will take the imports from this module, which is this nonsense. Create foreign scope. It takes a hash map from module name to list of identifier. It takes... Why would I need the module name and the module definitions? I don't think I need that. So I need only the imports, which is... So again... The list of import. Okay. And this returns the same thing. I don't need to do all of that. This is a maybe T. I'm gonna copy what I've done before here. Given some monad in which I can write stuff. So maybe T over that monad of the local scope, the foreign scope, which is this hash map path to an empty role. Oh, an empty roles plural here, that's wrong. Okay. Now, I think most of this will remain the same. Can I rename this module exports? It's just gonna get a lot simpler because declarations are no longer required as part of this, which is definitely easier. So this is going to be a hash map from module name to hash map path to non-empty role, I guess. Will I want the location there for errors? Wait, I thought I did. Oh, wait, no, it's fine. There's not going to be any errors there. There's not going to be any errors there. Can there be any error there? No, there can be errors in this. No, there can be errors in this. But this is still going to be a lot easier, because this is now non-empty name. So this is a lot easier. So now I change this to being for each import in the imports. Symbols is probably not going to be the name because this is going to be the list of exported identifiers. Which is going to be, okay, this error for a lookup of the import path into the module exports. I don't need to resolve them because I am not going to be... Wait, what am I doing here? I'm doing a... I am making a hash map from... This was a declaration, and I'm making it basically the name of... Why am I doing this? I guess because I needed the declaration for this, which I no longer need. I'm not sure I'm gonna have to keep this. Let's comment it out. It's a good thing. The upside of maintaining the big cache and not having to do any of this is I don't have to deal with definitions at all as part of this process. That's gonna make everything a bit easier. Because now... Indeed, I'm creating a single map for each of them with the import path. That's correct. From a list with, that is indeed correct. And I'm concatenating the non-empty list. That's fine. So that means this expression gives me a list of... It gives me a list of pairs of path, so fully qualified path, to non-empty role. Okay? So if I import a qualified name, let's do the exhaustive, that's going to be the easiest. This is going to be the easiest because I will take the list of all of the exported identifiers, which is a simple list of things. So that's just going to be for each identifier in the exported identifiers. Or I'm just going to make it as a map. Is that a concat map, actually? It is a concat map because I am making... I'm returning... Yeah, it is a concat map. I'm just going to do it like this. For each identifier, give me a list of the identifier to which we map the role. And I guess I can prepare the role as being... Oops. Make role will be doing a top level name, top level declaration of a name. Okay, so it's going to be for an identifier. It's going to be a top level declaration of name, the import path, plus pure identifier, and no arguments. So now this is going to be, for this identifier, it's going to be this, and it's going to be import path plus pure identifier. Okay, role identifier. So in the case of an exhaustive thing, we take everything that was exported from the module, and we create two entries in the local scope, the name and the fully qualified name. Both of them point to the same role, which is top level declaration from that specific module that uniquely identifies it. Okay, specific. So I have a list of names I'm importing from that. I am importing from that module. And that means for each name, where this is ugly is I'm going to have to do lookups on the list. That's kind of ugly. I guess I could make it a set. Maybe I could make it a set. There's a set of things exported out of a... Oops, sorry. Do you have some tips and tricks when it comes to reading Haskell documentation? Usually the Haskell documentation gives type signatures, but most of the time there is not a lot of examples or explanations on how to use the types. That's a very good question. I wish I had a better answer than just like experience. Like at some point you get used to reading the type signatures and seeing how they work together, but it really depends on the library. Some library are like if I look at HashMap, for instance, some of the function signatures, I would consider those to be fairly readable. Like, okay, takes a list of the hash map, returns a hash map, call unions. Yes, that one, the type signature is pretty clear. But if you look at lens, the type signatures of lens are not useful at all. Maybe showing lens to someone asking questions about type signatures in Haddock is not a good idea. If I look at, for instance, each, the type signatures there are maybe not the best example. Let's look at perhaps. Type signatures there are not super useful. So do I have a better answer than like, depends on the library. Some of them are better written than others in terms of like accessibility and readability and just experience. I'm afraid I don't really have a better answer. However, I will say for most libraries, open it in JHCI and call the functions. You will very quickly realize what's wrong. It's hard to get, like, the compiler will guide you along the way. So just trying the functions in the in JHCI is often the key. But also, the part about the experience is like most libraries tend to use the same kind of conventions in the way they name like type parameters, the way things are organized, the order of arguments in functions. A lot of those things have like I'll say hidden conventions, have some conventions that are not written in stone, but that most libraries adhere to. So the most libraries you've read, the more it is likely that a new library will have a structure that you will recognize from other libraries. But yes, GHCI, and also, are you familiar with the type arguments extension? If you're not, it's going to make your life a lot easier. For instance, in GHCI, if I look at, let's say, what do I want to do? Let's look at traversable. Let's look at fold. Let me zoom this a tiny bit so it's more readable. Import data foldable. So like fold is defined as takes a T of M, returns an M with T is foldable and monoid, M is a monoid. What does that mean? How do we use it? Well, if I use type applications, it might already be activated. No, because I'm not in the stack GHCI. I could look at the type of fold where T is a list. What is the type of fold if T is a list? It is takes a list of monoids, returns a monoid. Suddenly that like you can fold is maybe not the best example, but you can do this thing of like give type arguments to the type parameters and see how the type signature changes. For instance, if I look at bind the monadic bind, I get this thing for any monad. I can do the same thing of like, hey, what if my monad is list? And what does that function look like when M is a list? And it is, takes a list of A, takes a function from A to list of B, returns a list of B. That's concat map. So type applications like this to try to like, when you're using the types in GHCI, trying to see how the function signature changes based on what type arguments you're giving can be extremely useful. It's even more useful in the case of very complicated libraries that do like type families and stuff, where like the type will change based on what arguments you're giving. So try using type applications, given type argument, see how it simplifies to something a bit more readable. Those examples are a bit straightforward, but hopefully that shows you an idea of like how to try things in JHCI. I hope that answered the question. Perfect. So back to this. I think I'm going to make a change, which is I think at the moment what I'm using is I just have the list of identifiers that is exported by each module. The problem with this is I will want to check whether a name exists in the list of identifiers. And if I have a list, that means I'm doing linear search. It's not that big of a deal because most modules will not be exporting more like worst case a few hundred symbols, but it's still silly to do linear search when I can do better. So I think let's rewrite this. What we export at the end is not gonna be a list of identifier, it's gonna be a hash set of identifier. And as a result here, what we get as the cache of what we have done so far for our dependencies is gonna be a hash set of identifier as well. Which means we need to change one thing. Our local scope here is gonna give us the hash set of identifier immediately. There's no point in doing it later, which means here when I do the exports at the end, I'm gonna actually put this on 3 lines for readability. This is gonna be a hash set from list. Okay, I think nothing else needs to change, which means that here in create foreign scope, when I'm importing a list of specific names, I can do here, I can do an unless that name is a member of the hash set, which is the exported identifiers. Exported identifiers. Unless that is true, then I will want to report an error, which is this handle maybe function that I no longer need. I think handle maybe is just a report error of the thing. Yep, it is just a report error. So unless that name is part of the things that are exported by the module, I'm trying to import foo from module B, but like is actually foo exported by the module B. If it's not, report error. And the error is this one. And otherwise, I think this is the exact same thing here. There is a concat map again. So, but I think this time, yes, it's correct. I am going to use this traverse for thing to obtain a monadic list of values, which is going to be, well, a list of monadic values transformed into a monadic list of values. And then on that list, I'm going to apply the concat. Yes, okay. Because here actually I need to do a pure because this is not in the monad. This is purely on the at the list level. There's no error handling here. Okay, so this is correct now. Unless that name is in the list of exported identifiers, report the error. And otherwise, we output a list, which is again, I'm gonna say identifier. I don't want to use names since names has another meaning. And therefore, unless that identifier is in the list of the exported identifiers, report the error. And then here I can just copy and paste that thing here because it's going to be the same here, just indented differently. There we go. So again, that means in this case, we're adding two entries into the scope, one which is the unqualified name, the other being the fully qualified name. We don't do mixed qualifications, super relative stuff. Is either the name is fully qualified or it's not qualified at all. Okay. An import path is indeed the name of the module in this import that we're dealing with. Perfect. It is also simpler than it used to be, which is nice. And if it is qualified, then it is even better because that means that there's two ways to access the value, the name in that thing. There's the qualified version and there's the fully qualified version. So it's just introducing an alias. So it is basically the same thing as this. There's no need to handle errors, I think. Oh, except I have to make this back into a list, what I'm doing here. So it's going to be a to list here. That's fine. And this is going to be the exact same thing, I believe. And I think this is just a qualifier, actually. I'm going to indent this just for readability, I think. So here, what was I doing? I was getting name symbol from the list of resolved. Oh, this is because this might not be. This is a maybe identifier. There might not be a qualifier. I think I am going to actually handle it in two different ways. I'm going to say qualified nothing and qualified with just a qualifier rather than trying to handle both at the same time. Because I think this is going to be a lot more readable if I do it this way. Because if there is no qualifier, then the only way to make a reference to the value that I have imported in scope is fully qualified. So this is not even a concat map. This is purely a regular map of this, actually. This is the import path and, oops. This is very ugly. And so that way. So basically, for each thing that is exported from the module I'm importing from, the only way to make a call to it is fully qualified. Therefore, the key in the scope will be the full path plus the name, pointing to the role. If there is a qualifier, then there are two ways to call the thing. It will be just that name. Wait, no, that's not true. I copied paste the wrong thing. This will be pure qualifier, pure identifier. There we go. So it will be qualified by that name, or it will be with the regular full qualifiers with the full name. Which I suppose begs the question of, I don't think I handle errors for if someone imports something with the same. I don't think I handle if someone does use foo as, well, not, yes, use foo as bar and use bar. Because suddenly the bar things are in scope, the foo thing are in scope, but the name clash. I think it's perfectly valid to do this. It will result in name clashing in this, and that's annoying, but it's not the end of the world. Yeah, I think this works. I think this works as it is today. I will not get an error at this level, but if I ever do bar dot something, colon something, and it's defined in both, I will get an error message like, hey, do you mean the one in foo or the one in bar? Yeah, okay, I think that's what works. So that's ugly, but I don't think I need to handle it in any special way. Okay, so that should be the slightly easier version. Still not great, but it's a bit better than it used to be, version of the foreign scope resolution. And indeed, we still do the thing where we do a hash map from module name to the different things so that we don't consider a thing to be duplicated if it comes from the same module. So first we do the union by a module without taking into account duplication, and then we do union of all the things, of all the now unified modules, but we keep the duplicates because we want to be able to say, hey, which one do you mean? So now, that's exactly that. Except this is just non-empty name. Everything else has disappeared now. Context declaration doesn't need to exist anymore, because we don't initialize the declarations based on the imports. We initialize them based on the global cache. Therefore, the only thing we need to return is this hash map from path to non-empty role, which this is what it happens to be because this is no longer a name, it's a role. Role here. And therefore, I don't even need to do this. This is known symbols is an absolutely horrible name for this hash map. Oh well. But the result is basically pure of this. Okay. And now, I think we're done with rewriting. It is a lot more concise than it was before, and it is also better. So that's pretty decent. It doesn't compile yet. We haven't tried compiling in 3 hours, so that's gonna be fun when we try. Except, for instance, like this is create foreign scope. Okay. But this should be better now. Except the error handling is still terrible. We still short circuit way too quickly. We don't return any location information. We don't format the errors. Error handling is bad, but that's a problem for later. Now, we're probably gonna need to change a few more things. The resolve things are all gonna be broken. I'm gonna have to redo all of them. But this isn't where I want to start. I want to start here at Analyze Declaration, because it has changed. It doesn't take the name, for instance, which we will need to decide ourselves. And furthermore, each of those functions will be responsible for modifying the cache, our context cache, this one, with the resolved version of the declarations, which will serve two purposes. First, it means if we have a resolved version of the type, when we do type checking of a function, we can look at the resolved version of that type. And two, this is also the result of the analysis will be the list of symbols that we're building. And this is also where we're going to be putting the instantiated version of functions when we end up doing that. So I think this doesn't change in the sense of, like, if I do analyze of a declaration that has already been put in the cache, that means I need it for another reason. I don't need to redo it again. So, except now it's called context cache, which makes it even more obvious as being a cache, which is great. So if I do a lookup of, aha, I don't have the name of this thing. I only have the declaration. So the unique name of this thing is going to be, I'm going to need to get the module name from the monadic context, which is asks, not asks, it's view, because this is a lens I want to use. So this is view of info module name. This name will be a name with the module name I guess no one will ever call analyze declaration on a enum. That makes no sense. I don't think this will happen. Even if they do call it on enum value, I mean, like I encounter red for enum RGB something, and I say, oh, I don't know what that thing is. I have a declaration. I need to analyze it. It will point, the enum will point to the declaration of the enum. Therefore, the key in the cache will be the name of the enum. Despite the fact that every enum value, yeah, no, I think that works. Okay, so I don't want to say that it's the identifier of the declaration, because some declarations will result in more identifiers than one, specifically enums. Let's create the root identifier, which is just going to be the same. It's going to be the one for most of them, but that's the definition identifier from this. Oh, actually, yeah, I get all of them. For this definition, I'm going to rename declaration into definition. Okay, which means I need to change it back there again. Analyze definition here. So here, okay, the identifiers will be. The only thing is I need to use any of them as a cache key. The problem is this is a list, and I have no way of saying that like I'm not returning a non-empty list. I should maybe just return a non-empty list, given the few places where I'm using definition identifiers. Where am I using it? Here, and I'm using it there as a list. Wait, is that the only place I'm using it? Yeah, that's the only place I'm using it. I could just make that. Give me a non-empty list of identifier. That way I can always extract the first one without it being a partial operation because I am guaranteed for it to be non-empty. There we go. Let's go back to analyze declaration. Definition, actually. Okay, so do I need the identifiers for anything else? Aha, yeah, I need to check them. Okay, so that means I'm going to do something else. The names, exported names, is gonna be is a non-empty list traversable? It should be, right? There's no reason why it's not. Traversable, perfect. Which means I can do, and I will get a non-empty list as the output, which is exactly what I want. I can do for each of the definition identifiers of the definition, I get an identifier, and I do something in my monad. And what I do here is when there is a reserved identifier, fail. This is not a valid name. Um, diagnostic. There's a bunch of places where I have a name here in the arguments. Which of those will make sense with the new definition of name I'm using? Or would those need to be identifiers instead? Because this, in this case, is reserved identifier. Yeah, I guess, okay, name here is the unique name of... That is the unique name that identifies the declaration I am currently doing. But this might be the very name that's wrong. Nonetheless, that means exported identifiers is going to be this. The root name, which is going to be our cache key as well, which is going to be used for everything, for error messages and everything, will be the root. Yes, exactly. The root name will be name, module name, and the identifier will be the first one of the exported identifiers, which is guaranteed to always exist because this is now a non-empty list with no arguments. So that's the root name. Perfect. And now my exported names for each exported identifiers. If it's reserved, report an error that it is a reserved identifier in this root name. And otherwise, we return the new name, which is module name just pure identifier. There we go. And no arguments. So now I have my list of exported names, which I'm going to be able to use to populate the cache at the end of this function. This name I don't require anymore. Now I do this lookup using the root name, which is going to be my cache key for things that have for things that have more than one exported name. From this, I do a case. If it's already found, then I just return this definition because it was already found. I don't need to do anything else. Otherwise, I need to do the analysis of this declaration. I reset the state. Is it urgent? It is not urgent. I set the location. Where do I do? Oh, I do it here with the local. Okay. It feels ugly using local for this. The upside of local is that I don't have to manage the state myself. It becomes trivially obvious. Like when this returns, the local takes care of setting it back, but it means modifying the reader, which feels not great. I think it's fine, but I am not a huge fan of this. Okay, I'm just gonna change this name into a root name. I'm just gonna do it like this. Okay. I think it's fine to give them the name as part of this because it will be useful for them to have them for error messages. So I compute the name once here at the top level based on what's exported as far as identifiers go, and then I just give it to the analyze functions. I think that's fine. None of this changes. If there's a cycle, then report the error. Otherwise, add the current name into the stack of definitions that I'm going through. Why do I do this dec identifier? Why do I do that? I don't know. This doesn't seem to be needed. Which means I can do the resolved definition, which is basically based on the definition of this thing. Is it called declaration still? It should be called definition. And based on that, I delegate the proper function. That hasn't changed. And now what has changed is I need to add the new things I have done to my cache, but instead of being an insert, it's going to be a union of hash maps because I need to add it for every single name that is exported because in some cases it's going to be more than once. So this is going to be... It's going to be this nonsense, I believe. Let me look at control lens setter. State combinators, there we go, that's what I want. This one is for modification, which is not what I want. I want I want either this one, or there's another one which is the same, but for... Wait, I thought there was another one that was a bit... I thought there was another one in this one. Wasn't there? Huh. I was convinced. I was convinced there was one was the same thing as this, which is modify the target of a lens by using the union thing, but with the order reversed. I was convinced there was a thing like this. Huh. I'm surprised. Maybe it's a more recent version of Lens, I'd be surprised. Wait, which version am I on there? That's 5.0.1. What version am I on? That lens not found. How do I get stack version, is it? No. How do I get... Wait, is there a stack dependencies? The version of lens is 5.3.3. Okay. So let's go look at 5.3.3 instead. Let's go back to setter. And let's see if there is... Not that I think I need it, but I'm just surprised that I couldn't find it. I want the state communities because I'm in the state monad. So this one is the one I was thinking of, which is modify the target of a lens using yeah, there we go. That's the one I was thinking of. I wasn't hallucinating it. It exists. But I don't think I need this here because I think we've managed to guarantee that there was not going to be any duplicate in the first place. So I think this is just enough. And it would have been this. That's what I was thinking of. And now the hash map I want to add to my context is for each of the names in the exported names, that definition. With the location. So that is basically from list. Can I make it? Because this list of exported names is a non-empty list. Can I avoid having to convert? Can I avoid converting it to list basically? But I don't think I can. Fine. Okay, something is wrong with the alignment here. That's fine. We'll figure it out. So for each name in the list of exported names, sadly, the hash map from list doesn't take a foldable, it takes an actual list. To list exported names. So for each individual name, we are going to create a mapping from that name to a with location, because I want to add the location information to my cache for some error reporting later on. The location of the declaration and the resolved definition. What that means is that I'm also saying that like the red constant will have its own unique name in the list of exported things that will point to a specific definition, which is the one of the enum. That's going to be a tiny bit weird because there's going to be some places where I'm going to need to check, oh, I have this name here and this definition here for this path currently in my scope. I need to check whether this is one of the values of the enum or of the type of the enum, but this will be trivially be doable because the name will the last element of the path of the name will be either the name, the identifier of the enum, or one of the values, so I can differentiate that way. Okay, and with this, we have fixed analyze definition, I believe. There's going to be, yeah, we're getting closer to 3 hours without compiling. This is going to be a nightmare when we try. I'm just going to do a replace of declaration definition because I'm sure there's a bunch where I'm using it wrong. Well, not that many, actually. Okay. So let's do quickly then. Let's look at my resolve functions. I think this hasn't changed. The resolve callback with the magic about the AST phase, I think we need to keep the same. We might need to change this, however. Okay. So this is going to be actually the roles. Name not found. Do I rename this as an error role not found? I think it would be horrible for a user to see a role not found, but as far as internal consistency goes, I think this would be a lot better. So, what I do is, looking at my context scope, which I think is its new name, there we go. Using my scope, I look at the name that was given to me. If it's not found, I just return an error. That's a very simple error. You've tried to call like a thing foo that just doesn't exist in the scope. Perfect. Otherwise, I try to see if there's more than one match. If there is more than one match, that means, hey, which one did you mean? There's more than one thing in the current scope with that name. Written error, ambiguous path. Perfect. Others. That means here I have different roles for the thing. That's actually better. That's what I want. So error, ambiguous path, non-empty role. Okay. Then that means there's only one, which is this one, the role here. I have to resolve the type parameters. That makes sense. Okay, I think this is all correct at this point. Scope. Resolve name no longer should exist. This is resolve role now. And what I'm trying to do here is I'm trying to find if there is a declaration associated with that role or not, which will only be the case when it is a top level declaration. Otherwise, there won't. Because if it's pointing to a variable or anything like this, I will get the variable and which contain a type that which itself might contain a declaration. Actually, maybe I want to do that. Maybe I want to be smart about this. Well, it depends. For a built-in type, there is no corresponding definition. For a built-in function, there will just be no. So I will need to have a function definition for built-ins. For built-in function, I think, because I will need to be able to type check them. Built-in types don't have a definition. That's fine. Type parameters by definition don't have a definition. That's correct. Placeholder, obviously not. A function argument, I could make the case that maybe I want to associate the declaration of its type. But it's not guaranteed to exist because it could be a type parameter based on the role within the thing. But would it make sense? Would it make sense to just, like, will there be situations in which I want to handle, like, I want to handle whatever this thing is, I will need to know its declaration. I think it makes sense then to be smart and try for variables and function arguments. Let's give the definition of the type associated with them. I think that makes sense. Okay. So what that means is I'm going to need to have a function, an inner function here that looks up the name of the role based on the okay, so the name, that doesn't change, will be based on the path, still called path name, I don't like that, of the resolved path info. And now I have to handle all of this. If it is a top-level declaration, that's easy. That's just the name. If it's a built-in type, it doesn't have one. It's a built-in function. For now, it doesn't because I don't have built-in. I don't have declarations for built-in functions. Although I guess since I don't have built-in functions at all at the moment, I can just do that. This is never going to arise yet, but this is correct for the future. Type parameter, regardless of what it is, there is no declaration associated with it because I will not know what it is until later. A placeholder, that's also nothing. For a function argument with a given name and the function archetype, it will depend on the archetype. Actually, this needs to take a path info as a, it needs to take a role as argument. Because I'm going to need to call it recursively. It's not a type name, this is get name, yeah, I suppose. Okay. So in the case of a function argument, if the archetype is a by-value path, then it will be get name of the path name of that path. And by reference will be the exact same. Given the amount of times where I do this, maybe I will want to introduce a function. Which is going to be function archetype p returns a path info of p, which is just going to be function archetype is a case of by value returns this, by reference returns this. Maybe instead I can do get name of path name of function arg type of the archetype. Okay. And in the case of the identifier, a variable with an identifier and a var type, it is get name var type. Okay. Okay, so now when I do a get name on the root path, I might not get a name, which means I will need this is going to be a bunch of cascading maybes. I don't like that. So case get name of the path name of the resolved path info. If it's nothing, there's no unique name associated with that thing, which means the process declaration thing goes with the resolved path info and nothing. Can I write this as a sequence in the maybe monad? No, I don't think I can. If I do have a name, I could do it as a second run maybe t on top of the previous one. I could do that because this is basically a bunch of maybe things look up in a hash map and stuff, and I want to stop as soon as I get nothing, basically. Wait, no, this is no longer true. This is no longer true. If I do find a name, it should be an error to not find a definition for it. Because either it's coming from a foreign module and therefore it is part of the cache, or it is in the local file and it must be found. So if it has a name, it must have a definition. It might not have a name in the first place is the only thing. So, in which case I can do oh, this is going to be a bunch of cascading maybes. That's ugly. Because I want to go back to monad here. I want to look it up in the foreign definitions. Do I find that name in the foreign definitions? If I don't, I want to look it up in the cache. Have I already built a thing of this name in this module? If not, I want to look it up in the local definitions. And it's only an error if it appears in none of the three. That's gonna be a bunch of cascading maybes. Okay, so I'm gonna look for it first in the foreign declarations, which I can do with view s. I look at my info foreign definitions, and the function I apply there is a lookup of the name. I can do a case. If it's not, if it's just a definition, perfect. Process declaration. How do I want to call this? Because it doesn't necessarily process the definition declaration. It might not have a definition at all. I guess it's process role. I just process it to process callback. It's the callback. With the resolve path info and the just the definition if it was found. Okay. Otherwise, that's why I really want to see if I can make it, but I don't think there's an easy way to avoid this cascading thing because the types are different, and the types being different means I don't think there's a way to unify this cleanly. Let me think about this for a second. Can I avoid this staircase of maybes? Can I avoid the staircase of maybes? I don't think I can. Ah, well. Unless... Unless I use a monad alternative property, I think perhaps. Let me have a look at monad plus. Wait, is that another package? That's not, maybe not what I want. At plus. Where are you actually defined, monad plus? If I look in Google, it is in control monad. Okay. So I'm just gonna go read that instead. Monad plus, there we go. An associative operation. This is what I want. I want does it have a blanket thing of like if the in the contained thing is a monoid, then an alternative, then no, I don't. It doesn't seem to have that. Because what I wanted was alternative capital A. Oh, there we go. Yeah, it's the same. But I don't have the guarantee. Yeah, no, I don't think this is what I want. Because I was thinking maybe I can just get each of the different maybes by doing all of the lookups one by one, and then since they're not all the same type, I can't unify them with alternative on the maybe, but I could unify the result. However, the problem is... Oh no, that's fine. That should work. That should work. And is there a way with alternative? If I have, is there like an A equivalent of folding with alternative? Where I have a bunch of alternative and I want to pick one. Who goes to the rescue? What's the type of alternative? It's on an... Okay. So if I have an alternative F and I have a list of F of A and I want an F of A, choice. But it's not... Oh, a sum here in control applicative. Perfect. I think this is what I want. Because if I create a monadic expression in each of my maybes, it's not going to be evaluated until it is resolved. So if I do my a sum on the list of maybe monadic actions, I'll get the first actual monadic actions and I can execute it. Perfect. So I think that's what I want. So here in this case, rather than doing a big staircase of all of them, I'm going to look up the foreign definition. Which is going to be the result of doing uses info foreign... Well, I already hit here. There we go. That's what it is. That gives me a maybe value. Now I do the same thing for cached definition, which is one which we have already built in this module, but it was local in the first place. So this would be uses context cache lookup name. And last but not least, local definition for when it is one that we have, was local and we have not resolved yet, which will not be the same type of maybe as those two things, because those are resolved definitions. This is just a parsed one because we have not resolved it yet, which is fine because the callback is generic over which kind of thing it takes, which means here this is back to being a views of info local definitions. And it is, as usual, a lookup of the name. And now, what I'm going to do is get the action by doing an a sum of... I'm actually going to just introduce a... Can I partially apply this? I hope I... Can I do call equals callback resolve path info? I think I should be able to do that. So it's call on the foreign definition, call on the cached definition, call on the local definition. So this is now a list of maybe monadic action, and that monadic action is always the same type, because even if those things are not all the same type, the result is guaranteed to be the same. So by doing this with the a sum, I will pick the first of those that is not nothing in order. which means at the end of this, I can do a case here again, but only a second one, not like three like I was planning to, like three more. And that is simply, if it's nothing, then that's an error, but it's not a user-facing error. This is a dev error on our end. This is an internal compiler error because it means we've somehow managed to find a unique name that uniquely identifies something in the program for which we found no definition. That's not supposed to happen. For now, we don't have a good internal compiler error reporting mechanism, so it's just going to be a panic. Otherwise, otherwise, what we do is A is a monadic action in our monad that gives us the result. We return A. That's the value of this. It will be evaluated as part of the thing. There we go. Okay. Resolve roll has been done. Now, God, it's more than 3 hours with it trying to compile. It's gonna be a nightmare. I should take a break, but also I don't want to take a break until I'm done with this big change because I'm changing so much of the stuff. I want to try to reestablish a base before we can make progress again. Okay, so let's try to finish this. At least go over all of the resolve functions and see what changes. Resolve const value. What has changed here? Is that correct? Does it take a path info past? Oh yes, it's not an analyze const value. It is a resolve. So yeah, that's fine. So what this does is, okay, I have a path here. I have this name of something. I want to check that it is a const value because that's the only thing it can be. If it's not, that's a type error. And if it is, then you can give me the typed expression. So we are doing a resolve path that hasn't changed, and go here our function is a resolve callback that hasn't changed. And now the big difference is we are gonna get we still get the role and we get the definition. That hasn't changed. What we're saying here is that if there is no definition associated with the thing, then it cannot be a valid constant value because the only kind of constant values would be other constants, I guess, or an enum. So if it doesn't have a definition, it's wrong. And I guess I can even use that directly because regardless of what the thing is, it's not a const. Next. Otherwise, I have a definition. Oh, I still have the name as in declaration. I should change that. This is definitely not going to break a bunch of things. It's fine. Okay, not too bad here. Now the same thing here. Nope, this one's fine. This one is fine. Yep. This one is a definition, actually. Doesn't change. Doesn't change. That's a definition, yeah. I don't know why I didn't fix those ones. Yeah, I should probably just go back. Oops. Nope, that's correct. Okay. Okay, I need to change this one as well. Definition. Definition. Yeah, I really want to have a better error handling than maybe T. I'll have to figure out something. I'll that may be depending on on whether we manage to finish everything this evening. This might be something I plan for next time, which is how do we do better error handling than just like putting a bunch of maybe T everywhere. We'll see. That should be enough for now. Let's go back to where we were. Const value. Okay, so I did find a definition for the thing. If it's a type alias, that's not something that's valid for a constant. That's easy. Likewise for a function, likewise for a struct. If it is an enum, however, what does this mean? Reject type parameters? This is probably not where I should do that. This should probably be where, done where. No, actually, this must be done here. It's just it's annoying to have to do it everywhere. Maybe I could do it here in resolve role, where instead of just calling the callback directly, I do a very basic test of like, hey, you've tried to give something parameters where they don't make sense. Nope. I guess it depends. Like if in a constant I call a function with type arguments, type parameters that make no sense, the problem is not that the type parameters make no sense, it's that I'm calling a function. So maybe, yeah, I'm gonna have to duplicate that check. That's annoying. I'm gonna leave this as a to-do for now. What do we do here? Aha, so that's the original path. That's not what I want. I don't want to look at the original path to the name. I want to look at the last component of the name. But I don't know if the thing, I don't have the name. I don't have the name. I think I need to change the callback. That's gonna break everything again, because I think this needs to also take, because this contains the role, but it doesn't contain the name. But the name is only, yeah, so it needs to be maybe name with location. So it needs to be this tuple. So resolve role here, the call is going to be it's going to need the name here. So I'm going to define this here. This is going to be that. Create a tuple of the name and then call the callback. Which means every single place that does any of this needs to now. This is not just a definition, this is name and definition. And now this identifier is the last of. It's called again name full path. And now with this, I have the guarantee that it's either the inner name or it is one of the identifiers. If it's not, that's a internal compiler error. Okay, everything else here should be fine. If it's a constant definition, I probably don't need to keep this aligned with all the stuff there is. I have to resolve the definition because I need to get the value of the constant, which will call recursively the analysis of the constant, which means that if we have a cycle in constant values, it will be detected, which is what we want. Why do I need the path name for the resolve definition? I think that's no longer correct. That's because analyze definition used to take the name, and it doesn't do that anymore, which means I can remove the name from this. Which is a lot easier. Okay. Which means here I resolve the definition of the constant. The ugly thing here, however, is, although I could do... Could I do that? I could maybe change my definition of resolve definition. Because the problem is here is this. Resolve definition takes not the info like the enum info or the constant info as an argument. It takes the declaration, which is a constructor that says function declaration, like function definition, set definition with the info as an argument. So here I have to rewrap the definition to give it to this resolve and then unwrap it again. And I need to check that I've got the exact same that I had in the first place. And if I don't, that's an internal compiler error. That's never supposed to happen. But I do this all over the place because I don't have a reliable way of not doing that, which is a bit annoying. Could I rewrite this thing here so that it knows how to it's probably doable. But that makes it a class with two types. And how does that impact my constraints on the resolve? Or rather on the callback thing? No, I think the constraint cannot be on any, because at this level I don't. It needs to be for anything that can be made into a definition. Is this doable, or am I losing myself in a complete side quest that is not interesting? Basically, can I find I probably just need a second class, basically. Yeah, because what I would like to do is be able to express the type of this is actually... what I would like to be able to do is for this to be for some arbitrary... That's what I want, basically. With I such that it can be made into a definition. Because if I can do that, then it simplifies a lot of the code. The problem is, how do I do that? And do I want to make it as with location like this, or do I want to take the location as an argument? I probably want to take the location as an argument. So that would be something like location, this, this. That's what I want. But I need to have a qualifier, some kind of trait class that tells me basically how to construct a definition from that thing. Which I think is doable. Let's do that. So this would be still the same thing. Ignore the location, return just a thing unchanged because it's already resolved. In the case where it's passed, I am going to need to declare. Let's go back to the AST. No. Definition. I am going to make here. Do I make it here? Do I make it? I think I don't make. I don't think I need it as part of the AST. Let's make it here as part of the analysis. So this is going to be so it's a definition if I can make it into a definition by giving it a location and, well, just an I suppose. And you give me a definition for that phase. I guess two definitions from definition, which, okay. Okay. And now I just need to make a bunch of instances. Because now, put the AST back here. Aha, that's annoying. Enum info doesn't work. Because enum info, so I need to make it as. Oh god, this is annoying. Do I make a change so that the enum info is also parameterized by v, so I don't have to deal with the fact that it has a different shape? I'm gonna do just that, which is ugly, but there we go. I'm sure this is gonna break a bunch of things. Okay. So now I can go back to my definition here. I can make an instance for each of those. I can almost generate it with regex at this point. Because I'm just going to remove this first thing. There we go. Because I want to do, I have the name of the constructor, followed by between parentheses the type of the inner thing. And I'm replacing this with instance is definition for... Actually, I'm going to need to make a change. Because I need to extract. So this was, again, group 1 is this. Then I have between parentheses group 2, which is okay, there we go. So group 1 is the constructor, group 2 is the type minus the parameter. And so instance is definition of the type, which is the parameter 2, where to definition is going to be the constructor, which is this one, takes the thing, returns a definition. And from definition is going to be a case, a case of if it is the constructor then return that thing wrapped in a maybe. Otherwise, if it's anything else, nothing. I'm gonna vertically align this for now and insert a new line. Okay. That's ugly as hell. I have a few new lines that are wrong somehow. I must have captured a new line by mistake. So it's just a matter of fixing this now. Okay. I should probably make that a separate section in the file because it's a very specific thing, and then I can move this here. Okay, if this isn't broken, that means now I can convert a type alias info fairly trivially into a definition. What that means is that in the case of here, I am getting the location and some kind, so it needs to be for anything here that happens to be an I. So this is a is definition I. Takes the location. And there we go. So it takes the location and takes the info regardless of what that info is. What I know is that I can make a to definition out of this thing. I can wrap it in a with location that has the location that was given to me. I can then call analyze definition on this thing. Do I want to do it as... Yeah, I'm going to do it as a series of... I'm going to do it the other way around. I'm going to start with to definition info and apply with location and do the analyze definition. Except it's gonna be give me a it's fine. and fmap with case. It's nothing. Air ice. Because in this case, it's never supposed to be the case, and otherwise. Oh, I can just actually just do a fmap of maybe from maybe air ice. Okay. So now that means with all of this nonsense out of the way, I can go back to resolve const value. And here, if I do a resolve definition, I need the location of this thing. And the const info. Oops, where did I go? Here. I don't have to do this case and this thing because it is guaranteed to be the correct type because that is done now as part of the resolve definition. So now I guess this is just a fmap, just a const exp of resolve definition of this thing. Okay. Okay. Now resolve value, which can be anything that is a valid value in a given scope. So this can be a lot more things, I think. Because this will depend on the role as well. So if I don't have a definition for this thing, that means it was either a variable that was bound to a type parameter, something like this. It's something that's not bound to a type, to a top level thing. So that means what does that mean? I guess that means that, yeah, I don't need to actually fully resolve the thing. It doesn't. Do I even need to do the case on the definition, actually? Because in the case of a function argument, in the case of a let variable or anything like this, I don't care, I think, what the definition is, because it might not even exist. What I only care about is like, yeah, there is a type. That's the type there. That's the thing that's associated with it. So maybe just checking on the role is enough. And if it is an enum, then it will have a corresponding definition. And it cannot be a type argument because that would not make sense for an enum. So I guess this makes sense. I'm gonna keep this. That's the main case. And in this case, if it's an enum, I have to do the same thing I did before. The identifier is now this, because now this is name and def here. Same way it was the same thing here. Okay. That hasn't changed. That hasn't changed here. What has changed is I need to do that instead. Perfect. Next, resolve type. Okay. So we accepted the type. Anything that is not... No, I think I should be more specific than this. Because if I try to resolve a path and I get something that doesn't have a top level definition, that doesn't have a definition, sorry, then I need to handle more cases. Because if it is... I guess it would be an internal compiler error and I have to handle it. If it's a top level declaration, it should have a definition. If I didn't find it, I already have panicked at this point. If it's a built-in type, it's okay for it to not have. Built-in functions will have definitions at some point. Everything else is handled. Yeah, okay. That's fine. Resolve definition. That's a definition that got messed up. It requires the location of the declaration. Here's the name as well. And the info, and I can remove this thing. It's paying dividends already. Here I am checking the parameters. That's good. Okay, so I'm checking the type arguments. Everything is here is correct. I'm going to move this to the top because I tend to have all of the errors at the beginning. In def, I can just... Okay, so here I am checking the type arguments. Perfect. So here that's basically, if the thing I found is an enum, I don't need to check anything that's a valid type. Ah, shit, no, that's not true. Fuck. I need to check the same thing I'm checking here. This rewrite forces me to go over a bunch of things and find a bunch of bugs I had not identified, which is good. So if the identifier is different from the enum name, error not a type, I suppose. Error not a type. I guess I can do it as a when. Report error, and otherwise pure path. Okay. Next. Whew. Yeah, 4 hours and 10 minutes. It's been a while. Next, resolve struct. Let's see. I think this one is used specifically for struct expressions, as in, I'm evaluating the expression that constructs a struct value. Therefore, the name, the path here must resolve to a struct specifically. I don't think there's any other context where I need that. Maybe for field access expressions as well. So Okay, urgent. I suppose that's valid. If it is a placeholder struct name in struct expression, yes. I suppose the name of a struct can't be a placeholder. That makes sense. I don't think this is true, however. I don't think that is true because I don't think that is true because of type parameters. If I am in a function in which I have a type parameter t, and I make the assumption that that type parameter t is a struct that can be constructed with some specific fields, then the name t is valid in the context of a struct. But I just won't have a definition. Ooh, that's annoying. Ooh, that's annoying. Okay, let's see what we do in the case here. I can again simplify this. I can copy and paste that thing here. Because we've done all our work to simplify it. There we go. There's a lot of duplication across those functions. I will probably want to try to like extract all of this common stuff every time to a separate function, just because it means I don't have to redo all the same checks everywhere. I'll probably want to do that at some point. Okay. Do I do a result type? This is a result role, actually. Actually, I should do that here. When I do a resolve type, I should probably... I guess the assumption here is that the resolved version of a type alias will always point to the exact type, and therefore there's no need for me to do that. That's probably what it is. Okay. Okay. But here I need a struct, so I need to re-resolve the thing to make sure the type is a struct. Here I can copy and paste the same thing. Okay. Here I do the checking of the type arguments, that's fine. Okay, so the problem here is I am saying if this resolves to a struct, I have to know. That is annoying. I don't think this is doable. That's going to break a bunch of things, but that's the bug I have found here, so I might as well do it. This is gonna return a maybe, because when we find a type parameter we need to silently accept it despite the fact that it can't be type checked yet. Generic functions may be hated. So, let variables no, function arguments no, built-in functions no, built-in type no, but type parameter, come on, up, type parameter with some name. Pure nothing. Frustrating, but so it is. I guess, however, for constants, that's not going to change anything because for constants, I'll be able to say there's no such thing as a type parameter in the case of a constant. Give me the actual value. This will be useful for functions, however. Okay, so we fixed some bugs while doing this. That's always good. Try resolve enum from name. This is forecast, I believe. And this would be from roll. Now we've changed everything. Let's resolve roll with go. And go regardless of what it is. How does it work? Oh yeah, this is a do block in the maybe monad. That makes sense. So maybe enum info on whether, yeah, that makes sense. Substitute types, I think none of it here has changed except maybe name, because this is a role now. It's a name of a type parameter, it's fine. Yeah, I'm gonna change that. I try to be strict on like role identifier name whenever I can, especially since I'm changing everything, but sometimes, yeah, okay, this is an identifier, but it's the name of the type parameter, it's fine. Set type parameters, except for like some naming like this, nothing here should have changed. Context names. Context names no longer exists. This is the scope. I am saying that, okay, those type parameters are now in my scope as this parameter role. Okay. Type diff doesn't change. Type matches doesn't change. Okay, I think all this is fine, which means we're finally arriving at the analysis functions after all this time. It's been a long evening. When we try to compile this, that's going to take ages. Especially since there's going to be a bunch of typos everywhere. Nice definition. Yes, that's the one we've already done earlier. So we've already done this one. Now, analyze type alias. What do we do? Except it's not a name, right? Or is it a role? Or is it a name, actually? No, it might be a name. It is, I think, the correct name. This might be, okay, this might be a place where we're going to have issues where a bunch of diagnostics will mix between role and names. I'm going to have to fix that. But otherwise, set type parameters, that's correct. Resolve type. Oh. That will call resolve type recursively, but that's fine. That's fine because that is fine because cycles in type aliases are not valid in the first place, so this recursion is fine because we want to detect a cycle if type A depends on type B and type B depends on type A. I think I can't imagine a scenario in which that would be valid to have. I guess technically it could be valid. Ah, that's annoying. I don't think in the case of our language it makes a difference. I can see in Haskell where I think Is something like this possible? I don't think so. I don't think it's possible at all. So I think it's fine. I don't think type aliases can be mutually recursive. Can they? I'm fine not having recursive type aliases. I'm okay with that. So type aliases, struct, enum, few things have changed. The only thing is now type enums are typed. Convenience with other things. Except now this no longer works because because this is no longer the same type, so I have to decompose this now. I'm just going to do it this way. And that's enum values then. And that's pure enum info, enum names, name, enum values. Nothing has changed. It's just I need to unwrap and rewrap since those are no longer the same type. Okay, now for constants. Type hasn't changed, that's good. None of this has changed. Yeah, I think none of this has changed. And I don't think any of the function calls here have changed. The only place that has changed in this whole mess that I'm certain of is here. Where I think if we get a maybe, the only case we get nothing, well, we get a maybe, the only case we get nothing is we found a type parameter as a name of a struct, despite the fact that type parameters don't exist in constant definitions. So I think here that is already impossible. Therefore, this I can do a from maybe air ice on this. Nothing else should have changed in this. Of course, it will have changed. Some things might be broken, but in theory, it should be fine. This struct fields should not have changed at all. And then analyze functions is where we were. And hopefully now that means when all of this compiles, we can go back to the analyze function thing we were doing for all of this time. Okay. That's everything in the analysis file. After 4 hours and 24 minutes, let's try to compile all of those changes. I'm sure it's gonna go great. If we look at the diff of everything we've done so far, it's gonna be oh, when is diff stat non color? Do you have color? Huh. There we go. Yeah, 331 insertions, 262 deletions. That was yeah, this is gonna be well, let's go for 1 hour of debugging this now. Because I am convinced it's gonna take a while. Okay, so role not in scope, despite the fact that I do import representation name. That's because I have a circular dependency between the things, and I need to go to my boot file, name ashes boot, to say, hey, that's not the only thing that's there, there's also a role. The definition of which is not required to just avoid the cycle. Okay. Here I'm gonna have a bunch of places where enum info is gonna be missing its type parameter. Okay, we've moved immediately to... So AST compiles, name compiles, diagnostic doesn't compile, but that's progress. I am guessing that for enum out of bounds, I will always want the resolved version. Let's see. Let's see if this poses a problem. Okay. Oh. Ooh, those errors are in the parser. And I know why. Okay. Parser. That's because I have renamed all of the... Actually, I do as a regex. All of the declarations I have renamed as definitions. So there we go. Type alias declaration is type alias definition. There we go. I've noticed that my hair keeps getting worse the longer I stream. Oh, could not load module that have these, but I'm not using it in the end, so that's fine. Because I keep all of my windows closed to avoid noise from my side being picked up, and it's warm in this room. Non-empty roles, this is non-empty role singular. Same mistake here. Okay, no more errors in this file apparently, great. I spoke too soon. Context scope doesn't exist as top level scope, it's top level names. It should be top level scope, let's be honest. There we go. Except top level scope I think doesn't exist anymore, does it? Oh no, it's called top level scope still. Okay. So I reset the context scope to the top level scope. I reset the font type. Yeah, okay, that should be fine now. Unused imports. So that's the kind of error I'm happy with. But there is a do here. Oh, but this might be a indentation problem. If I do this, we'd be happy about it. Yeah, it is. Okay. Is there a way to express sequence of fmap sequence of traverse? Is there a better way to do this? Is there a function that does this? Google, my friend, what do you have to say? Because sequence, fmap sequence of traverse means that I have some function from A to some kind of FB. I have some traversable of A on which I do the traverse, which gets me a T of FB, which being a traverse becomes an F of TB. But then I do a fmap sequence, which means the B is not a B, it is something else. It is an MB. So I apply the the traverse. So I get a traversable of f of mb, but it gets flip. So it is an f of traversable of mb, and then I apply the sequence within the f, which means it becomes an f of m of tb. There is traverse m, which might be somewhat close, but it is in a weird library that I don't want to depend on. Okay. Sequence, fmap sequence of traverse it is. I might just put it in a new line just for readability. There we go. Okay, data these is not used. Okay. Because I said type, not data. Hashmap strict doesn't... Oh, it's called LMs, not values. It's called resolve definition. Which I'm sure I have. There we go. Resolve definition. That's all the nonsense we've added this evening to do the auto unwrapping. Oh, why is it also compact? There we go. Ah, I have a few others that have escaped the renaming. Okay. Should be all. Oh, yes, wrong arrow here. Expecting one more argument to... Resolving an enum info is always a trivial thing to do. So I could do the resolve definition thing. Because what I want is here, not I have to specify, this has to be a resolved one. Because it could already be resolved, and that's the... I can make a past one resolved, but I can't make a resolved one past. I guess I could actually, but that's beyond the point. Which means I have to do... a sequence. Because this is the maybe monad, and I get a maybe action, and I want to then... Because then it's no longer pure of the enum info. Wait. Wait, is that valid? I guess maybe is monad fail, which means a pattern match is not an error, it's just nothing, right? So if I do... let's do data color equals red or blue. There's no other color in the world. And I just want to do a do red again. Red from just blue, which is a pattern match pure red, I suppose. If I do that, it is obviously in the maybe monad. No, okay, that's fine. Deriving show. Yeah, okay. Monad fail for maybe just means that on the pattern match, it just... So I can just do that here. I'm in the maybe monad. I try to match this constructor. If I don't get that constructor, then it's fine to get maybe I don't care. And here, instead of pure, I'm going to need to resolve that thing. So I'm going to need to... Is it resolve definition? With the location of the declaration and the enum info. Mod declarations doesn't exist in this scope. Did I change that? I thought I hadn't. Because I do have the module there. st module. Oh, I did change it. Probably a replace that was a bit aggressive. Do I want to keep it changed? I guess it is. The declaration is the syntactic thing, and now I have extracted that and I have the definitions. I guess mode definitions is actually a better word for it. Yeah. I could go other way on this one. Okay. Okay, I'm just gonna recompile. Found whole mode declarations, mode definitions. Just gonna try to see if there's any other. There isn't. Okay. Okay, all exports doesn't exist in this context. That's because I've probably named it something different. It's called exported now. That's a typo. It's hoist maybe. Aha. Couldn't match type role with non-empty role. That's more interesting. So expected a hash map from non-empty identifier. That's the path. That's the module name to hash map non-empty identifier role. Actual. So I have somewhere a place where I'm just putting the role directly rather than putting a non-empty list of roles. That's the problem. And indeed, right there, that's where it is. In all of those. Actually, I don't need to... Oh, but I don't have the identifier yet. Aha. But I could already do pure here. Which means I don't have to put it everywhere. Okay. I'll try again. Hoist maybe. Probably because I need to import it. Control trans maybe. Which I thought was in my prelude, actually. But I'm only importing maybe t and not actually importing anything else. And I need hoist maybe. Okay. Wait. Ah. Control monad. Just maybe. Okay, hash set identifier with actual type identifier. So exported, that's because here the hash map, I have not updated the type to be a hash set. Okay, I think I'm gonna take a 5-minute break. I'll be right back. Because I need to do a quick break, but I want to finish this evening. So I'll just take like 5 minutes and I'll be back. How do I do this? I don't have a OBS scene for be right back. The only thing I have is my technical issues. I'll guess I'll just do that and be back in 5 minutes. Okay, test. Looks vaguely okay. Sorry for making you all wait. I just really need a quick break, get a snack, refill my drink. Let's get back to it. We were in the middle of trying to compile 4 hours and a half of work and going through all typos and small mistakes. So far, only small mistakes, so nothing that has just like made us rethink everything. Create local scope. Annotated definition passed. Oh, I'm assuming that yes, this is the declaration with its location. Which is what I want here, but for the definition identifiers, I need to get the located thing within. Okay. What are you saying here? With the actual type name. Oh, yes, because I have changed what a name is since this was written. Because now this is that. It's a non-empty list made of this non-empty list plus this element at the end. Actually, does non-empty list have an operator for that? Because that would be convenient. Prepend, but there's probably not the other way around. There is append, actually. Oh, yeah, it's appending a full non-empty list. Okay. Just search. No, there is this one. I would probably need to replace that with like actually proper containers, non-empty list, probably like non-empty sequences or something like this. In the meantime, this is fine. It's not very elegant, but it's good enough. Okay, so here, I'm just gonna zoom this out a tiny bit. Let me know if it's too small on the stream. Just because I want to be able to fit the whole thing in the screen for a bit. What are you complaining about? You are complaining about... Oh, you want the actual with location for this? Because... I suppose because the error message expects the location in there. So it's probably just that, actually. Okay. And there we have the thing again, where the location requires the location, and I no longer have it. Why do I no longer have it? Because here the definition does have the location. Oh, but this is probably since I had the mismatch here. It's probably confused then by now, so I should recompile. Okay. Expected locations. Oh, interesting. So I need to fmap location of this. So I guess it's no longer it's definitions. So it hasn't changed. And that's location of the definitions. Okay. And a local scope. That's a non-empty role versus role thing. So I have again the problem of my local definitions, which are local scope, which is the second part of the thing here. That means this needs to be a non-empty list, therefore this needs to be a pure here. Okay. What are you complaining about here? Non-empty role versus list of role. Oh, I suppose this is expected to be a non-empty. And of course, yes, this needs to include the one I already matched, so it needs to be this. Okay. Yes, this makes no sense. Wait. No, the whole point of this was if I find a name, it must have a definition. Therefore, here I know this is the just case. However, this thing doesn't know it, so it needs to be an F map of the tuple of the name into the maybe to then do the callback. Let's rename it definitions. Foreign definition right there. Wait. Expected maybe with location? No. That doesn't make sense. So call is callback, which is this resolve callback thing, partially applied with the path info, which is this argument, and combine with an fmap of name. So this expects a maybe with location. Should fmap the name within it, so we get a maybe name with location, and then should do the callback. What's oh, of course, yeah. This is not called within. It's called directly on the maybe. Except that's not what I want. Because I want. Yep. What I'm saying, what I want is basically find the first non. I want to find the first non maybe thing and then always give it as an argument. That's not the same thing. So what I want to do is instead I have a maybe something here, but I'm applying this function on it where I don't have the maybe. So I want to do this and then put it in a maybe. That's what I want to do. Couldn't match type passed with resolved. That's because I did not give a type to call, and as a result, it was monomorphized to the first call site, which is here, where it's called on a resolved definition, despite the fact that it might also be called on the past definition here. So I need to give it a type. Call is something that takes a definition at a given phase, and which needs to be an AST phase, I guess. And also, I can just copy this actually. It's gonna be easier than trying to do it again. It's that, except the path info result has already been given. The name is already. So the only thing it's taking as an argument is the with location. thing. Yeah, that's what it is. Can I align this a bit so it's a bit more elegant? There we go. It's this R here, but you're not aware of it, so I'm gonna need to do a for all R here to make the R into the scope of this function so that the R here can refer to the same thanks to the scoped type variables language extension. The constructor placeholder should have no arguments, but has been given one. Yes. Okay. Could match role with name. That's a kind of error I was expecting a bunch of. But I suppose that's because error not a const should be taking the role, not the name there. Yeah. So diagnostic, not a const. I have a bunch of ones here that take names, and I'm expecting half of them to actually need to be a role here. I'm preemptively gonna do that, and we'll see if that's correct. Okay. Couldn't match role with path info resolved. I thought... But the first argument is clearly the first argument to get name, and the only one when I do a backslash case for is definitely a role. So... Is it because here I have this get name that is wrong, and I should do path name of it? Probably. Oh, the error isn't the same, so it's probably that. Const expr. Missing a letter. Top level declaration has one argument because yes, now it's no longer a module name and identifier, it is the unique name. We're past the 5-hour mark. Oh, I forgot my phone somewhere. Oh well. Here info must be in scope. I'm gonna stop aligning things that don't need to be aligned. Aha, I've been writing too much Rust. It's this in Haskell. Enum name, enum info. I have the same problem here. This is the enum info. I'm supposing that this is not the right type for the function. Oh, no, it's because I have added a maybe to this thing that is not reflected in this thing here. As in the callback gives me a maybe thing, but the type here didn't match. Okay? Next. Ah, yes. Now all of those callback functions need to be name and declaration. The name is never used, so maybe I'll have to remove it from this. I'll see. Maybe I will actually use it for some error messages. I guess I could have... I could have given the name for the error, not a thing, not a struct, not a type, and so on. Although, no, I guess I will need to be able to emit those errors even if I don't have a name, because I'm pointing to a role that doesn't have this. So, no, I think this is correct. Worst case, I'm just going to get another warning as error of like, hey, that thing is matched but unused, and I just add another score, and that's fine. It's better to be able to do more. This expected name, found role. I'm gonna do the same thing. No, actually, if I have a definition, that means I have the name, the incorrect type parameter count, that one can only happen when I have a definition and I'm comparing to the definition. So incorrect type parameter count takes a name. I'm not gonna change that. However, I'm gonna go immediately to all of the error incorrect. There we go, because all of those will be wrong. I should have more, or at least I should factor them away. There's so many places where I don't check the number of type parameters. At the moment, there's a lot of places where if the user does like int with type parameters, like int parameterized by int, my compiler is like, it's fine, that's an int. And I should reject that, but I have not done the checks. I have a bunch of to-do check type parameters. Okay, this is wrong because here this needs to be a maybe, so here it's just. And that's again, that's a maybe of name and declaration, which is actually name and definition. Okay. Yeah, I guess I should do it slightly differently. I should do it as with location, and this thing. So I extract everything I need. And that's just fmap second, which is a binding in the maybe monad. So in case where this doesn't match because it's the wrong constructor, that's fine. That's not an error. That's just a nothing. So this should all be fine. And here, then I have location that I can pass as an argument to result definition. There we go. Can match type resolve with enum resolved. What do you mean? Oh, I guess this needs to be in a maybe because I am in a maybe monad. So this is a maybe monadic action, and I do a sequence to get a monadic maybe of the thing. Okay. Should be all of it for here. It was. Oh, because here I do the to definition, I wrap it in the location, I do an analyze definition, but here I need to back from definition and then from maybe. So this is from definition and from maybe. There we go. Context definitions is not in scope, and that's probably because we've changed the name of things, and I believe the context definition is in the context cache. Which makes sense. Here we start by checking the cache, and if the thing was not in the cache, then we update the cache with the result of the resolve definition that we've just created. Context cache indeed. Try resolve enum from name. I'm assuming it's because it's called from a role now. Yeah, resolve target type, those are roles. context names, this doesn't exist anymore. Context name is the scope. This is the function argument. So yes, I add the argument to my scope. Except I should rename this as resolved role for consistency. I'm going to be renaming some names into roles for a long time. Okay, so analyze block. What am I doing here? Oh, this is the thing where I reset the scope at the end of a block. So I analyze a block of statements, which will change the scope because it will introduce new let bindings, it will have loops, it will have other things. But at the end of a block, when I exit the block, things that were defined in it exit. They are removed and they are removed from the scope. And I don't think there's any way for them to persist. So it is a simple matter of get the scope at the beginning of the block, get the result of traversing the block, and restore the scope at the end. Try resolve enum from name, that's role now. That's in the cast expressions. Okay, is that all of the errors? No, okay. Lookup identifier. I guess lookup identifier is just, is there anything in scope? So I guess non-empty role is correct there. And here I have a problem with role instead of, yeah, okay, let's try to see this. Warning name shadow. And here for warning name shadow, I want the role, not the name, because I want to be able to say it shadows something that is not necessarily unique within the program. It could be shadowing like a variable, it could be shadowing something else. Shadow, this is a non-empty role, and I'm assuming as a result, yes, the other thing is also a role. Type parameter shadows variable, or the other way around, or something like this. Couldn't match type, that's a Louis location, it was expecting, and we've seen that before, so that's going to be the located of this thing. Why do I have a semicolon here? I've been writing too much Rust. Type variable p0 arising from a use of callback. Oh, this is, I am giving as the callback type is parameterized by some phase p in which we are, which means this callback accepts either a definition that is passed or a definition that has been resolved, which means I can call the same code regardless of whether I have found a definition that was already resolved or not. However, here I am explicitly giving nothing, which means there is no argument to this that disambiguates what the type P is. So the compiler is confused. And I suppose it's just going to be a matter in this case. Since it doesn't matter, I'm just going to say resolved. But it doesn't matter, I could do any of them. It doesn't change anything. No instance for EQ role arising from the use of this. I guess it makes sense to have this. I am worried, however, that this is used wrong, because if one of them is placeholder or something, where is that use? Type diff and create type diff. Let's use here. No, okay, I do handle this somewhat okay. I do handle type parameters. So that should be fine, meaning it just means I need to go back and add this to my roles. Will I need generic and will I do hash maps? Do I have any hash maps from... I don't think so. My hash maps are from names, not from roles. So I don't think I need hashable. Oh, I get name shadowing errors. That's great. That is good news because those end up being this are warnings elevated to errors that only happen when there's no more errors in the file. So we take those. It just means I'm using something called location here that yeah, that is override that is shadowing something else. It's gonna be lock, it's fine. Same thing here. We are at the point where this compiles. I would be surprised. Yeah, there we go. But it compiles in the part where I was expecting it not to, so that doesn't count. What it fails to compile now is we don't have yet a proper like top level binary compiler thing for the everything we've done so far. But I have a very small main here that I use for testing purposes, and I have completely changed what we export out of a module that we have passed. Now we have this resolved module thing that has completely changed, which means all of this is no longer working. So what that means, what is dependencies? That's the get of this exec state, okay? Okay, so that gives me that's not entirely wrong, except this is no longer a tuple. This is a resolved module diagnostics result. And the arguments have changed as well because I need two things. So my state here will be two hash maps. The first one will be the def cache, and the other will be exports, which means I have to give this to, this is, yep, def cache and exports. Oh, actually, this is not correct. This is diagnostics first and result, which I will decompose later, deconstruct. When the diagnostics are not null, print everything. Okay, is result. We did get the resolved module with the exported stuff and the new definitions. This first. There we go. And what do we do in this case? Do I modify them? Yeah. Might be easier to just... It might be easier to just put a tuple. The first is the def cache, so that's the def cache union the new result part, which is the new definitions. And the other is the exports, which is just an insert module name exported in the exports. This goes away. This is now a tuple because it's the result thing, which is the definitions and the exports. Actually, this needs to also be a tuple there. There's a pair. And I think since I'm interested in the definitions, not in the exports, I think I'm just gonna not look at the exports at all. And instead of doing this, this is going to be a name and a declaration. Which means I can't do that anymore. It's just going to be this directly. Which means I'm gonna do that. Okay. The only thing is, I will probably want not to print like this. I'm just gonna do it here, I suppose. This decla name thing, that's going to be, for now, I'm not gonna bother too much. This is going to be a no, it's the other one I want. How's it called again? It's not this one that I want. Not interleave. Is it intercalate? It is, and I had the wrong type. Okay, that's why. It's intercalate I wanted. I wanted intercalate with this to list of the name full path of this name. There we go. Okay, that should be fine. Symbol doesn't exist. It's called definitions. File whole name full path. I am missing name in the scope. Oh, because this intercalate, I don't have overloaded strings. I don't have Oh, no, it's because intercalate expects lists. And therefore, oh, there's probably a text intercalate, isn't there? There is. Okay, and now it compiles. 5 hours and 22 minutes. But we've done it. Yeah, it's been quite the evening. All of this for no benefit in terms of features this evening, but at least we have something a lot cleaner now, which was the goal. And I can test a few things from last time. This was supposed to test. What this was this supposed to test? That this is supposed to type check because at type of analysis we have no instantiation of the function, and as a result, we don't know what the type t is, and depending on what it is instantiated as, this might be valid or not. In practice, it will only be valid when t is int, but at the moment of analysis, type checking is circumvented by the fact that this is not known. So, unless I've broken things badly, and with everything else being commented, this should compile. It does. This is unreadable. Let me zoom this out a tiny bit. I should try to add color to this mess. Okay, the constant is correct. I am more interested in foo here. Oops, that's what I meant to do. Just gonna. Okay. I'm interested in foo. This function definition, which is named foo, has a fun parameter named t. The first argument is b, which has a role, which has a type argument, which is by value, which is a path info. The name resolved, its role is type parameter t, no parameter argument. That's fine. Oh, I should. There's a few places where I should probably check that I'm not giving. I probably don't want to support higher kinded type arguments to my functions. Maybe I want to. It's fine. Would I want to support higher kinded type arguments to my functions? What would be the catch there? It might be doable if I'm giving the name of a struct with no type arguments. I would just resolve like, hey, that's the path info, we're just missing some arguments. I think at the moment I would reject it because the number of type arguments is wrong. Potentially it might work, but I would need to change some things. If I do change it, I will have to add a bunch of checks in. Like I have to add a bunch of checks everywhere, and if I don't, then I will have to add checks that type parameters never get type arguments. There's a bunch of places where I don't check that type arguments are correct, and they're just ignored. I need to change that. Oh, also now enum values are correctly exported. The symbol main green points to the proper definition of an enum. So now the names are in scope, even if imported from another module. And yeah, foo type checked because, yeah, okay. So, yeah, we renamed name into role, we've introduced a proper name, we've redone all of the logic of context resolution for definitions, and it seems to be working. That's... I'm just gonna rename a few things, just to make sure I don't have too many that contain still the word declaration when now it's definition. Top level declaration is correct. Create local scope, those are definitions. Okay. Gonna check this still compiled, and if it does, I think I should probably stop here because I've been streaming for 5 hours and a half, but I want to make a tiny bit more progress, I think. Oh, and now this clashes. Okay. Hmm. I don't think I'm going to attempt to make small incremental commits for all of this evening's work because that's just, I've broken basically everything. Well, I think at this point, which I think I might do a tiny bit this evening because I would like to continue a tiny bit longer. I just need to go back to the analysis of functions. Let me commit this, push it to GitHub. There we go. If I go back here, so all of this, I'm going to zoom this out even if it's unreadable on stream, just for the shape of it, because this file is big. And now a bunch of this is helper functions like, hey, I have this name, I need to check that it is actually a struct, or I need to check that it is a valid value for my constant context, and so on. And at the bottom of this, I have the functions that like take a past thing, transform it into a resolved thing. And I have done most of them. I am only missing function. And function here at the end is I have started. It does the analysis of parameters, of the return type, of the arguments to the function, and so on. And it then goes to like analyzing block of the statements of the function, which is there, which like sets the scope and everything, and then goes to analyze statements. And this is where it's starting to miss some things. Analyze statement is not like, for now, it only tries to analyze continue, break, return. Everything else is just undefined and will crash. So like a let declaration for a variable or anything, which is like an if, that's just unsupported. And that's because to finish implementing return that I was doing, I have to do this monstrosity, which is I have an expression in the context of a function. And that is big because the expression type is big. That's the number of different constructors for an expression, which means I have to write I do a case on this, and I have to do one branch for each of those possibilities. Like, what does this mean in the context of a function? How do we analyze this in the context of a function? Yes, exactly. Functions is where all the good stuff happen, which is why I've kept them for last. They're the most complicated ones. And I was at the beginning of Tuesday's stream, before I got sidetracked by so many different things. I was in the process. We finished cast in the context of functions, which is basically try to see if we can resolve the type and the values at compile time. If yes, immediately do the cast. fold in the constants, like replace the values and so on. If we can't, because we don't have the runtime information, then just leave the cast just resolved. Like, oh, the expression is this thing that comes from this argument, whatever. And we had finished the casts, and I moved on to, we did path expressions, which is just a very basic thing I'm calling a variable, basically. And that is just a matter of resolving the value, which we did. And I was doing the field access expression when I realized the problem that was the impetus for this big refactor this evening. What if the expression I have on the left has a type whose definition is not in my scope because it is not in this module or in the module that was imported directly from this module? Basically somewhere in the transitive thing of dependencies, which forced me to reconsider the whole thing and develop this like global cache of definitions so that this module, while being compiled, has access to the full cache of all the definitions of all of its dependencies and their dependencies transitively. So now I can be certain that if I do like resolve this as a struct, I will have the information. Well, unless, it's a type parameter or something. So here, analyze function expression, sub-expression, okay. So this is, okay, the left-hand side of, I have like a.b, I have to check that a is a struct. If it is a struct expression at compile time, that's very convenient. It means I know at compile time what kind of struct it is, and I can go check, I can go inline this, basically, probably. But I need for that oh yeah, I don't even need to do anything else. I don't even need to go look up the definition. That's convenient, because if I have the struct expression at compile time, the struct expression contains a non-empty list of identifier and annotated expression. So here I will have just a field of like, hey, this name matches to this field, and it has already been checked by the recursive thing, so I know it's correct. I don't have to do a lookup of the struct. I can just extract the field. If the field is not found, that's an error. And otherwise, yeah, I just return the like expression that is within it, which might be known at compile time or might be not, but that's just like the struct expression was known at compile time. Now, this is the general case. I don't have a struct expression there. What that means is I don't know. Well, I could try to match to see. I could try to match to see if it is like an int expression, a character expression, like a literal expression of some kind, and reject it immediately, expected struct found int. But maybe the better way to do this is to look up the type of the thing. Because I have resolved the thing, so I have a struct type there, which means I have the role of the type of the struct, which will tell me that it's a type parameter or it's a type or something. So I should be able to resolve the struct from this. So I should be able there to get the struct info. And I think it is with a simple resolve struct of the struct type, I believe. Well, of the expression type of the struct type, I think. Because, oh wait, no, it's already decomposed. So no, that's the struct type. Okay. Let's go have a look at resolve struct. Let's see if it also works in this context or if I have to introduce a new copy of it. Text to path info. Ah, maybe original path is not actually required anymore. Oh, no, it is. Okay. So what do we do? If we find a type parameter, that's fine, that's not an error, but that's pretty nothing. We don't have information about the struct because it is going to depend on the type parameter. not instantiated yet. We cannot do anything about this. Okay. Sorry, I'm thinking about how I will do instantiation. And I think what I will do is I will traverse the entire definition of the function to replace all instances of type parameter with. I will have to replace all instances of type parameter with the thing recursively, and then I'll have to redo. It's going to be a nightmare. Instantiation of functions is going to be a nightmare. Anyway, nightmare is going to be verbose. But otherwise, if it's a placeholder that doesn't make sense, it could be a placeholder within a type argument, but as a struct type, it doesn't make sense. Type parameter, we accept it, otherwise we don't. Anything else, if it's a type alias, then I'm gonna go through it to make sure that I get the proper thing. I really need to deduplicate these things. I do the same everywhere. And for a struct, that's perfect. Resolve the definition, check everything. Yeah, okay. But this gives me a bunch of things because it gives me the type of the struct that I don't care about, I think, in this case. Do I actually resolve struct? With the changes I've made, do I need the resolve type still? Oh, I guess I might want to, just in case there was type aliases in the way. That way I will have the proper type name in the thing. Yeah, okay. I think I want to do that. So it makes sense to keep this, okay? Struct info resolved. And hashmap identifier, and that's the type arguments that have been provided because we do support partial, like we do support not having the type arguments so that they can be inferred, or that is, or wait. Does that make sense for an expression? Does that make sense for an expression in the context of an expression and not in a in the context of an expression where I don't have the actual structure? I'm not resolving the type. I'm just checking, A, the type associated with this is a struct. I don't think I care about the type parameters. Hmm. Because it's already been replaced as part of this, right? No, it has not. Interesting. Okay, so what does that mean? Okay, so I have on the left-hand side an expression that I've checked is a struct. If I get nothing, it means the type of the struct is a type parameter. I can't check anything beyond that. It's fine, will work. Or we check later, rather. If I do find the struct info, then I will need to figure out what the type of the result of extracting the field is. And that is the name of that is the name of oh, I don't have to worry about this because the field will be a hello, how are you? because at this stage I don't have a expression to construct a struct. I have an already constructed and type checked expression, which means the fields will contain their own typed expression. Therefore, I can just check the type of the field. I don't have to use type parameters at this stage. Okay. It's been a long stream. I've rewritten half the analysis module because I found a big mistake at the end of last stream. So most of the stream has been making zero progress in terms of features, but just rewriting everything for preparing for the future, which was fun. It took like 4 hours and a half of changing everything, and then like a solid 40 minutes to make everything compile. But yeah, basically refactor stream. The thing I've changed is at the end of last stream. I sorry for people who have been here since the beginning. I think it's the third time I explain it. But I realized a problem I have, which is I have this problem where I am at the moment I'm doing the analysis, like name checking, type checking of expressions within functions, and I realized, okay, I have an expression that contains a struct, which is perfectly valid, but I will need to check the validity of that struct by looking its definition, basically. Like you're doing .x on an expression that happens to be a struct, I need to check that x is a valid field in it, which means I need to look up the definition. What I realized last time is that when I was doing my import logic to analyze one given module in isolation, I was importing the definitions of the things that were imported into scope. So if I import if I'm compiling module A and I'm importing a struct from module B, then the definition of that struct will be in my scope here and I can access the definition. But if module A imports a function from module B that represents a struct that was defined in module C, and A doesn't import C, A doesn't have the definition of the struct in its scope, meaning I get an expression of type struct, perfectly valid, and I have no way to look up the definition. So what I've changed is basically applying the same logic that GHC does, which is I keep a full cache of all the definitions across compilation units that is given as an argument to a module. Like, hey, here's all of the definitions across all modules, meaning if you end up finding something that was defined somewhere else, it's fine if the module you're currently compiling does not import that actual structure from anywhere else. You should still be able to look up the definition of it. So I had to rewrite this whole logic of like we maintain a cache of all of the definitions across compilation units. And now I can go, after 5 hours, almost 6 hours of work, I can go back to what I was doing, which is continuing the gigantic case switch of expressions within the function, because that's the number of branches there is in an expression, and I have to handle all of them. So I was here in a field access expression. If the struct is not at compile time, that's easy. Otherwise, I have to call the resolve struct thing on the type of the expression that I have, because I don't know the shape. Like the shape is not a shape I recognize as a struct. So it could be anything. It could be a function call. It could be, yeah, exactly. Name and caching is hard. Exactly. But like this expression could be not something known at compile time, it could be anything, but I do have the type, so I can do a resolve struct that's going to do all of the lookups, and either throw an error if we can determine that the thing is not a struct at this point, or either tell me nothing if it's a type parameter, because I don't know what the type parameter is at that stage because I haven't instantiated my function yet, or best case scenario, it can give me the struct info. So now I have two cases to handle. In the case where it's nothing, that means that was a type parameter, and therefore, as anything that has type parameters, I cannot resolve at that stage because I haven't instantiated my function. I'm applying like a C++ like logic to generic functions. I don't have traits or anything like this in this language. So basically, whenever a function has like a type parameter, basically the type checker short circuits, doesn't do any type checking of the type parameter. When the function is instantiated, we retranslate the function to do all of the type checking, basically kind of like how C++ does. Uh, Except, a lot less complex than C++. So if I do find nothing, that means I don't have the struct info because that was a type parameter. Therefore, what do I emit as being the resolved version of this struct expression, of the field access expression? I believe that in this case, I have no way to do any type checking, and therefore I just need to return. I think at this point, I just forward whatever type parameter I have, basically. Which means, basically, that this is going to be a field access expression, but the resolved version of it. The type will be whatever the type of the underlying thing is, because if I have some type parameter t, anything will need to be rechecked. Whatever type I surface now is meaningless. I'm just going to resurface the same type. So this is going to be... Let me just open the AST on the side. Field access expression is the annotated expression and the identifier. So I guess I don't even have to do anything in this case. I cannot resolve this any further. Therefore, I am gonna just... that's the left-hand side. I'm just gonna say that's the left-hand side unchanged. And the identifier is the same because I can't type check further than this. This will be type checked when the function is instantiated. However, if I do have this, then I have access to everything that the resolve struct function gave me, which is a bunch of stuff. Most of it I don't care about in this context, I believe, because I'm not trying to check a structure literal. It's giving me the full unique path to the type of the struct in question, including type arguments. Okay, so that's the resolve type. I need that. And the struct info. And the mapping of type parameters, but the thing at this stage, I don't care about that. I'm going to copy this, so I have it with me at the bottom of the screen, because downside of streaming with the screen zoomed out like this, like zoomed in, is I have very little context around the thing I am writing, but that's fine. Here. So here, let me put a comment. I will have, in the case, this will now be the resolved type name. Because the type name that is here in the typed expression, I guess could be a type alias. It's probably not the case. It's probably already resolved. It's probably going to be the exact same thing as this one. It doesn't hurt to use the probably one that's been properly resolved anyway. Struct info. And then this part I don't care about, because at this point, since this is an expression of type struct and I have already... Wait, no, actually, I care about this. Because I don't have... Okay, let me think. So this is an expression of type struct. That means that all of its fields must be known. Some of them might not be available yet because some of them might be type parameters, but at this stage, there should not be any placeholder or anything in the types. All of the types should be known. Let me just quickly check that again. So here, either all of the parameters were given or none of them were. And I guess resolve struct. I'm saying allow placeholder there. Do I want to change this? Do I want to say that placeholder don't make sense at all when I'm resolving a type that was supposed to already be resolved? Probably. Although I guess it cannot happen. Like if it happens, it's an internal compiler error. We should already. The only way to create an expression of type struct is to use a struct expression. There's no cast to struct. And at the call site of the creation of the struct, then all the types must be resolved. And at worst case, there are type parameters, but placeholders can't be propagated beyond that. If they can't be solved, that's an error. So as long as my struct expressions are correct, then there will not be placeholders in the type of the arguments, okay? Meaning that after that, because here I'm not changing the type arguments. Path is the one that was given to me that contains either none of them or all of them. But here I'm assuming that it must contain all of them. Okay, so how do I use that when I do constants? Which is here, I think. Yeah, there we go. At the end, I have resolved all of this. So at the end, I am putting all of the type arguments as part of the path, which means if the expression was built in the first place without a cast, without compiler shenanigans, that means that when I arrive at a field expression, then I can be somewhat certain that I have in my mappings, I have a type for every single type parameter of the struct. Okay. If I don't, I can assert compiler error. I don't need to surface that as an error to the user because that's not a problem on their part. It would be a problem on my part. So, with this in mind, I am trying to access a field in an expression that is not known at compile time. What do I need to do? Oh, I think there's an error here because I am returning a typed expression, so I need to figure out the type of this. So this will be a typed expression where the type will be the same because I don't have any information, so it's just going to be the struct type. And the inner expression will be this, but the type is being surfaced. Okay, so here, the first thing I want to do is I want to check that the name I want to find which field this is in my struct. So struct info, where are you? There we go. Okay. So I suppose since it's just a list of value, an empty list of values, I am going to have to do a very simple locate of the thing. So what I want is the type of this. I want this part here. I want to know what the type of the field is. So the field type is going to be the result of doing a find, which is exactly the same thing as this, basically. except this is going to need to be in the monad given the use of on nothing and the report error, but that's fine. And here the fields are the struct values of the struct info. Okay. If I don't find anything, report error. The user tried to access a field whose name doesn't exist in the definition of the struct. That's a problem on their end, not mine. So report the error for this and abort the evaluation of this expression. But now we have the field type. What I need to do is with the mappings that I have, I need to replace the mappings because, for instance, if it's a structure that has like a type argument t or something, and that field is defined as a vector of t, by now I must know what t is. Therefore, I must be able to know in the current context what the type of that field is. I do have a substitute type function somewhere. There we go. Hashmap identifier to path info resolved, path info resolved. Perfect, that's exactly what I want. I think that's literally exactly what I want. So let's go back here. Sorry for flashing the screen that much. This file is getting very big. So here, resolved field, resolved isn't the correct word. Fixed. Fix is not the correct name either. I guess resolve is fine. Field type will be the result of calling substitute types using the parameter mapping. I call it mapping here, or maybe param mapping on the field type. Okay, that gives me the actual type of the field in the context, fully known, should be fine. If the name wasn't found, that's an error. And that should be will that be an internal compiler error, actually? Depends on how substitute types is implemented, I suppose. It will be an internal compiler error. It should be found by now. Okay, perfect. And now I have an expression whose content I cannot analyze at compile time because it's not a struct expression. I have validated that it is a struct, either because it is a type parameter or because I did find struct information without finding an error. I have checked that the field exists. I have resolved the type of the field given the information about the struct I have found. I can now emit a resolved version of this, which is going to be very similar to this. The result of this thing that cannot be computed at compile time will be a typed expression, the type of which will be of the field type, because we have determined this, and it is, and it is a field access expression that hasn't changed, but now the left-hand side is this typed expression. That has been resolved, maybe simplified, and the right-hand side is still the field that I know is valid. Okay. Okay, so that should be all of it for field access expressions. Perfect. What's next? Also, I've been at this for like 6 hours. I should probably stop soon. But a tiny bit more. One more. Ooh, call expression. Oh, this is going to be complicated. Okay. Let's get started. We found a function call. Call expression will be a path info, so the name of something with maybe some type arguments, and then type parameters, and then some arguments. So we're going to have to resolve the function. That's going to be a new function to write we don't have yet. We're going to have to then resolve all the arguments. Then we'll have to find the function because here type parameters don't matter. I am supposed to find the function information to be able to compare the type of the arguments to the type of the sub-expressions I was given. And then if all of that is correct, oh, I'll have to check references as well. Because would it make sense in my extremely limited notion of references in this made-up language? Would it be fine for two references to the same variable to be given in the same function call? Would it make sense? I think technically it does as long as they're the same type. Because by reference just means when I move my stack around for the function call, it means basically rather than making a copy on top of the stack of the value that I'm giving, I am just moving whatever value is at the top of the stack and then using that basically. And that just means both of those pointers will be pointing to the same address. It's going to be complicated and it's going to be a mess when doing the code generation later, but I don't see a reason why it should be forbidden. It will lead to weird things. It's going to be bad, but it's not theoretically invalid, I believe. Okay, so I don't have to do that check here. That's good. So that's the function name, function args. Except those already exist as lenses, so I should probably change that. So first, we are going to need to resolve the function for the fun path, which is a function that doesn't exist yet. So I think we should start there. Then, for each argument, in order, the order matters, we will want to do resolved args is going to be they're just expressions. So it will be a traverse of analyze function expression of the arguments, giving me a list of the resolved version, which is a typed expression. Okay. So that should be the function info. Because there's no way, even in a generic function, I should be able to find the function. There's no way to make it. There is no function type arguments. There's no function pointers. There's no anything like this. So I should be able to like see the name and say that's this function and it's defined there. So I should always be, if I don't find a definition, it means that's a mistake in the name. So I'm fairly confident about this. Of course, it could be wrong and there's going to be written an error, but that's fine. If it doesn't throw an error, we're in this case here. Now, what do I do with this while I have it? Oh, I guess I can check the reference because I am supposed to use a different syntax for reference arguments. So I can check that the arguments are probably properly given as reference. And since references are not allowed in any other context, yes, I can assert at this point that they were given by reference. Okay. Okay. Because there's no reference type or anything like this. Then I can do a bunch of things. I can do return type. And actually, I already have something like this at the top of analyze function there, which is this. Where is it? There we go. Where's the unit in there? Oh, and I do it here from maybe unit type. I'm going to do the same thing here. This is a from maybe unit type of this big nonsense. Placeholders don't make sense in the function return type. That's nonsense. And there shouldn't be, yeah, it makes no sense here. And I don't think it's even possible in the first place because they're not specified at this point, which means something recursively should have been wrong. I think at this point this is completely moot. But, you know, let's be explicit. Maybe make it as a fmap from maybe unit type of a traverse of all of this. Or do I make it the other way around? This is fun type on which I apply this traverse, and on which, oops, and then I which apply the fmap. There we go. So that tells me the return type of this. If it was not specified, then it must be a unit type. So the expression, the type of this expression of the function call will be a unit type. I could probably try to see if the function can be inlined, but I don't. I don't want to do inlining at this stage. I think it would be way too early for that. Both in terms of like compiler faces and this whole project. Inlining is not something we have given a lot of thought about yet. So I think I'm not going to bother about that at all. And even then, I think it wouldn't be there. I would probably, when we have already the IR, and therefore we have a lot of the simple assignment form that makes doing substitutions a lot easier, I think. Yeah, this is not the place to do inlining at all. Okay. Well, I guess unless I have built-in functions that can't be expressed within the language, even then they will be at the IR level. So yeah, okay, not here. So I have resolved the arguments. I have resolved the type. I haven't written the resolve function thing yet, but I'm assuming it exists. When I'm done with this, what do I have to do? I have to check the arguments, I think. Because the actual function call won't be in line, so the statements within the function I don't care about. Oh, that's a problem. Oh, it's a problem. How do I deal with recursive functions? Here I have made the assumption that I have a function info, which would be the resolved function info, which doesn't exist if I am calling the function that, you know, I'm currently defining. That means that resolve function cannot give me a function info, because then it would have to decide if it's. I do have for loops in the definition of the language. I don't have them implemented yet. If I look at the resolve statement, another statement here, at some point, one of those statements will be the for statement, but it is not done yet. But yes, I will have for loops in the language. I mean, yes, but recursion is nice. It's nice to be able to support it, but it is doable. The only difficulty there is this: I need to basically. I cannot do the full analysis of the function, because when I try to resolve the function, I might get the one I'm currently already analyzing, which means I would be in a infinite loop that would be detected and would just like be an error if I were to try to like get the full definition of it to finish building the full definition of it. That means I cannot do that. My resolve function has to give me a partially resolved version of it, and the only thing it needs to do to partially resolve it is basically resolve the type of the arguments and resolve the type of basically I need to do a thing where it gives me a fake function info that does not contain the full result version. That's gonna be tricky. But that's doable. What if I wrap it in a still a function info? That means the code of this function will remain the same, as in I called result function, you gave me a function info. I don't care if it's the wrong one, like it's a fake one, it's a dummy one that contains partial information, as long as it contains everything I need to be able to finish doing this. I will need to return more than just a function info. I am going to have to return as well the mapping from type parameters to values, so that I can do the same substitution and analysis of like, oh, well, okay, this function call is actually with those values. And if the function call is, damn it, it's going to be monstrous. I need, let me finish my thought. I am going to need to, as part of this resolve function thing, I'm going to need to get, okay, what type arguments were given to that function, if it required any, and then I will be able to do a match of like, okay, those were given, those were the expected ones, I have some things. Placeholders will have to be accepted because I want to accept placeholders so that type inference can happen. But I will need to do the thing where like I match all of them, and all of them will need to be either I have to redo the logic I've done for struct expressions, where I will need to make sure I can identify all of them, or worst case, find type parameters, in which case the type checking is deferred. However, there is going to be one more thing I will have to do, and that is, if this function has generic arguments and all of them are known at this point, none of them are type arguments, I will need to register this function as being instantiated, because I will need to build the instantiated version of that function. I will need to build the type check version of that function. But I cannot just recursively, while I'm doing this, like, go instantiate this function, because it could be this very same function that is not resolved yet. So I will need to maintain a queue of functions that need to be instantiated that I will do last when everything else in the module has been done. God, there's so much work to do. Um, okay, I've been at this for almost 6 hours and a half. I should probably stop here. So it compiles. I'm just going to do that. I think I'm just going to start making the resolve function, and I'll stop there. So let's go to the resolve part of this monstrous file. Okay, I have resolve struct here, try, okay. There is a lot of commonalities between resolve struct and resolve function, so I'm gonna copy it from here. I'm gonna zoom this out a tiny bit, let me know if it's too small. So here I will get the same thing, except here I will get the function info resolved, which is not a real one. It's probably gonna be a dummy one because I don't need to fully resolve the function to be able to. In fact, do I want to do that? Do I want to construct a fake function info when in fact that's not what I need? What I need is the arguments and the type. Those can be resolved at this point. But basically, I need 3 out of 5 fields. I think building a dummy function info is probably fine. So this is going to be the return type, which means allow placeholder. Yeah, I will want to allow placeholder for this. Okay, and here's my callback. So this callback can receive either a past an unresolved version of my definition or a resolved one. It is able to handle either, meaning I don't have to write it twice for like, oh, we found this as already resolved from another module or from the rest of the module, or we found it but not resolved yet because we haven't gotten to it yet. And I can decide what I want to do in either case. I think in the case where I did not find a definition for it, that's an error. There is no possible role, variable name, parameter type. None of those can result in not a function being resolved. So if that happens, report error. Error, not a function. Which I think doesn't exist yet, so up. Which makes all of this here simpler. Then we do find both its unique name that uniquely identifies it within the symbol map and the definition. I will want the name. Because, oh, unless I do the registration here. Maybe I'll do the registration here? Into the queue of things to be instantiated? Yeah, I can probably do that as part of this and not have to let the function expression worry about it. Maybe that makes more sense. It's like, you resolve the function, the type arguments are all known, put it in the queue. Okay, so I did find the definition. If it's a constant, a function, an enum, a type alias, in all of those cases, I don't have to do anything. In all of those cases, that is not a function. Now, here we have, except this is the struct def case. And this is the function def here. So here is where I have to be tricky. I cannot call resolve definition on the info. That will not work. That will break recursive functions. So I have to be a bit smarter than this. Basically, this is gonna be something of like along the lines of like, that's still fine to do. I have not made any assumption about this. The return type is gonna be oh, that's gonna be complicated. I have this resolve definition function that is able to take a definition that's either not resolved or resolved and go resolve it, basically. But it's not able to do partial resolution of other things. Could I do a resolve definition on this by removing the body in the first place and creating it as a dummy name? That's gonna put it in the cache, though, is the thing. Which I don't want to do. So I'm gonna need to find a way to extend my resolve thing to the path info and function archetype, despite the fact that this is not what they're meant for. Hmm. Okay, so I'm not gonna finish this evening, but I am gonna leave this as a thing that compiles. So I'm gonna leave it with resolved args is undefined. Resolved archetype is undefined. To do next time when I figure out how to do this. That's all I need. Then I can do the same thing here. Either all of the arguments have been given or none of them. If not, the correct amount has been given, report an error. Otherwise, do the mapping. Path params will be the resolve types. Yeah, that's fine. And as a result, I can return here, no just because there's nothing. I need to remove this nothing. This may be here. That is not correct. This will be the mapping, but first it will be a fake function info with the real identifier. That hasn't changed. I'm tempted to just deconstruct it here. That way, this is just the fun name. The fun params haven't changed. What am I doing? Oh, because, yeah. I expected params here. They're just fun params now. Expected. Okay. And so the fake function info I'm building from scratch will contain the fun name, the params, the resolved args, the resolved type, and no body, because that doesn't matter at this stage. Okay, so that should be fine, given that I find a way to write this part here, where the type of the parameters and the arguments is not known at, like, it can be either resolved or not. So I'm gonna have to write to extend my type class system that I've done for resolving definitions to be able to handle things that are not definitions. Which, come to think of it, is not that complicated, is it? Yeah, it's not monster. It's just a path info. Would that just be a resolve type? Yeah, okay, I can probably do that. If I go back to analyzable, God, this file is big. Yeah, 200 lines. If I go back, I'm gonna zoom this back in the second I find my place here. Here. I have this class that says that, like, I can transform a definition. Um, uh, if it's already resolved, it's a no up. If it's not already resolved, it calls all the machinery of resolving. I can just introduce a resolve type, which will take a path info at that phase and return a path info resolve. When the thing is already resolved, this resolved type oh, it can't be named resolve. Because I already have something called resolve type. I'm gonna need to rename those things. I think resolve definition is a bad name in the first place because that's not what I've been using the verb resolve in the first place. So it is closer to analyze, but analyze is already done. So this is like the maybe analyze kind of thing. Is it a refi? Is it a coalesce? What's the verb here? What am I doing? Force is also a possible verb here for this. I think force is a good word because it also hints at how dangerous this thing is. Okay, and this is pure in the context where it's already done, because we take the path info, we just put it in the monad. The interesting case will be force type, which given some path inf, which is I think just resolve type. Oh, I need to decide if I want placeholders or not. Which I guess I can just leave as an argument. There's no reason to decide. Although, no. I don't think there's gonna be any other... let's keep it. There's a French saying of like, if you can do more, you can do less. And that's exactly this here. If this is able to be specified at call site, I don't have to make a decision now. That's better. And so this becomes literally just resolve type. And now this ignores the first argument to be pure. Okay. Perfect. Now I have to do a quick resolve definition into a force definition. Okay. And now I can go back to resolve function. And here my arguments are going to be, I will want to I'm going to do an F map on the list and an F map on the function on the tuple within it. So this is going to be an F map of something on the fun args. And what that is going to be will be force fun arg, a function I'm going to define separately. For the resolve type, this is going to be a lot easier. This is going to be a traverse. Actually, this is a traverse, not a F map. This is going to be a traverse of force type. And force type here is going to be with a forbid placeholder because this is going to be a function call of the fun type. Okay. This is only missing one thing. I need to define force fun arg. Oops. Wait, no, I want to be at this level of indentation +1. I want here force fun arg will take a function arg type and do the forcing on it, which will be basically, if it's by value, the result will be by value of f mapped of, no, with the path here, I suppose, of force type of, I'm going to use a helper for this. Force fun type is this. So this is now force fun type. And here, force fun type of the path wrapped back into whatever the argument was by reference. Of force fun type. Okay, and that should be all. So now we should be able to bypass the restriction and be able to do this partial analysis of recursive functions, build a dummy placeholder function info that contains only the information we require for the analysis of a function call. Yeah, I should be fine. And now I will be missing, I'm going to leave a to-do for next time. In this nonsense here, I will need to, oh, there's a few things I'm missing. Okay. To do perform type parameter matching, to do validate arg numbers and type. And at the end, this will be outputting the same call expression, but with everything resolved, because we will know exactly where things, how things, like we'll have finished resolving everything. There was something else. We want to do parameter type matching because we need to figure out the type of everything. Oh, we're gonna need to do parameter type matching on the return type as well. That's fun. Okay, and then finish the analysis here. And there's one other thing I haven't done, which I'm gonna leave a to-do for next time. Back into resolve function, which is here. Where basically I'm going to have to maintain a queue of int functions to instantiate in my state for the module. And when I am done analyzing every single function, and therefore I have everything, I'm guaranteed, I'm sure of it, I will take the resolved version of those functions and I will make the type checking again, but for the instantiated version. Okay, now I make this compile and then I stop here. Pass error in this because possibly a missing do. Is it because it needs to be like this? Probably. Aha. Oh, okay. I thought this would work because I am in a context where... Huh. Oh, is it just that I need to make... Yes, yes, yes. It's just that I need to give... It's a monomorphizing problem. Those functions are written in such a way that, like here, force type, force fun type, they are they would work for any type parameter p that is like a phase, but they're gonna just like match whatever first call set it is. They're gonna be monophized. I think I have to introduce here that they are indeed for any phase p that happens to be analyzable. I'm gonna copy. I'm gonna copy from this. This is what it is. Wait, it's fine. So it takes a path info resolved and returns a maybe t analysis m of r, which means I need to make sure r is in scope. Wait. No. It gives me a... It takes a path info p. I am getting tired. I'm making mistakes. Path info resolved. That's the whole point. It takes any of them and returns to me the resolved version. That's what it is. And so I might introduce just some spacing here just for readability. Okay. And the force fun arg here is going to be very similar. The difference will be that it's going to take a function argument thingy, function archetype, and we'll return a function archetype resolve. Okay, now with those being generic over the thing, This means here those calls should be fine because they don't require resolving the type of P, so that should be fine. Couldn't match type resolve with past. That's never good. Oh, what do I have here then? Oh. Do I need then? Okay. So here the problem is, since I have a typed expression, the type I have is a resolved type, which means a lot of the mechanics are different on this. So I need to change my resolve struct. Wait, no, I can't change my resolve struct. I'm gonna have to duplicate it, which I don't want to do. Because at the moment, resolve struct, where are you? You're below this. Go. Takes the path to it and tells me everything about it. And in this case, it's like, oh, I already have the role for it. So it would be basically replacing this resolve path with the resolve role. Which means I might want to make, since it's going to be the same anyway, I might want to introduce all of this as a separate function and make two different versions of the resolve struct based on whether I have a name or I have a full role already. Maybe I'm gonna, for now, I might comment this out just because I want to make this sure it compiles for this evening and then stop, basically. Because I am getting tired. It's been close to 7 hours. Undefined for now. Couldn't match expected type. Okay. Yes, of course, now this is also giving me the mapping. Which I'm going to also add to the undo undefined here so that it doesn't give me issues about it being unused. Couldn't match type path with resolve, and that is the problem. Yes, at this point, the resolve type, it's already going to be resolved at this point. I don't have to do that. So this is just going to be the from maybe unit type. Defined but not used. Defined but not used. That seems to be all. Okay. Still passing the weird stuff we had before. This compiled. I'm gonna stop here for this evening, I think. I guess. Okay. Whew. Yeah, 7 hours is too much. I'm gonna go take a break, have a drink, and go get some sleep. Thank you everyone for tuning in. That was fun. That was a lot of progress. That was a big refactor for for good reasons. Uh, yeah, next time, next Tuesday, I suppose, gonna be more work on all of this nonsense with functions and structs and see how I can start to deduplicate. Maybe that's what I'll start next Tuesday with. Maybe I'll move stuff to a new file because this file is the analysis file with like its 1200 lines is getting extremely cluttered. I might start moving some stuff like the resolve functions that, given the context, take things out of like try to match things out of it. A lot of them end up being fairly single use, so I'll maybe move them to a new file, start looking at like how can I deduplicate some of the analysis I do in the different branches because I don't want to have to repeat myself every time. Add some of the missing to-dos for like checking placeholder and checking like type names and everything, and type parameters, and start generalizing some of them so I can give either a role or a path and do the resolution based on which context I have. I think, yeah, I'll start with this next time, start moving some of the functions outside of the big analysis module, start cleaning them a tiny bit, finish the resolve function, resolve struct, and then go back to function expressions. Okay, well, again, thank you everyone. That was fun. As usual, I'll try to update the recordings on YouTube as soon as I can. I tend to not be super proactive on this, but I did the big batch I think last week, and I'm not missing any recording despite Twitch killing them very quickly. I just need to like do I think last week and this week, and I'll try to do that this weekend. And I'll hope you all have a good weekend, and I'll see you all on Tuesday.